We are here in the Overloon War Museum, standing next to a British World War II era Challenger tank destroyer. This is a very rare vehicle, as only around 200 of them were ever produced, and this is the last one left. The defining feature of the Challenger is this high-velocity 17-pounder anti-tank gun mounted on the very mobile, very speedy chassis of the Cromwell cruiser tank. And in this video we will be exploring the Challenger. We will be going over its technical features using this last example available to us, but we will also be going over the doctrine behind it, why it was developed in the first place. We will be discussing its role within the Armoured Reconnaissance Regiment, but most important of all, we will be talking tactics, how it was actually used in the field against a real opponent. And to do that, we will reconstruct the tank battle at Somme on the 20th of September 1944, because it was right there that Challenger tanks of the 15th and 19th Hussars went into battle against German Panther tanks of the 107th Armoured Brigade.
Seen on its own, the A30 Challenger is already a fascinating vehicle, combining revolutionary armor-piercing firepower and exceptional mobility with an armor layout that can at best be described as antiquated. But the Challenger is even more interesting beyond the nuts and bolts, as it occupies a central but often overlooked place in the history of British tank development and armored warfare in general. That is why this story will not be limited to the Challenger in its physical form, but will also use it as a vehicle in the figurative sense to explore the broader topics it ties into. The A30 Challenger will serve as a central thread that weaves through the complex history of tank design, armored doctrine and tank tactics in the European theatre. These are broad topics with varying levels of abstraction, so this story will be told in distinct chapters that tackle one subject at a time. The first part encompasses theory and includes chapters on doctrine, design, organization and tactics. The way these topics relate is that doctrine is the natural starting point, as this is the theoretical foundation that leads to a physical design. Doctrine is a bit like software that can be updated all the time, while design is the commitment of resources to produce actual hardware. Ideally, you want your software and hardware to be in harmony, but if real-world use reveals the doctrine to be flawed, the design will also be flawed. And while you can quickly adapt doctrine, you're stuck with the design until you produce something better. In the meantime, making the most of the hardware you have is again done through adaptable software, namely combat organization and tactics. Even a tank design based on flawed doctrine can still perform well if used properly. In short, doctrine leads to a design, and the capabilities of this design dictate the best organization and tactics. How this dynamic applied to the Challenger will be the central theme of Part 1. The second part will then show the Challenger in practice by reconstructing its finest hour at the Battle for Somme during Operation Market Garden. There are 3 preliminary remarks. The first is that the term tank destroyer will be used to refer to the Challenger, even though this wasn't the correct British designation used at the time. However, calling it a tank or a gun tank doesn't distinguish it properly, whereas self-propelled gun doesn't do it justice. Tank destroyer, on the other hand, clearly and precisely describes the role it fulfilled. The second remark is that the traditional cavalry terminology of British armoured organisation will be used where applicable, meaning a regiment is a battalion-sized unit, a squadron is equivalent to a company, and a troop is a platoon of 3 or 4 tanks. Lastly, all measurements have been converted to metric for the sake of consistency. You're watching Digital Battlefield Tours, and this is Teaching Tactics. A tank is an armored vehicle designed to carry about firepower. This definition, once understood, simplifies the problem of the employment of armor on the battlefield. The essence of the tank is the armored fighting vehicle. It is something that has armor, can fight, and is a vehicle. In other words, it has protection, firepower, and mobility, or when packaged together, mobile protected firepower. These three characteristics form a triangle that every armored fighting vehicle, whether it's a main battle tank, scout car, or self-propelled gun, has a place in. They all have some sort of firepower that is made mobile up to a certain level and has a degree of protection against certain threats. On their own, neither of these characteristics would be all that novel. The artillery has plenty of firepower, cavalry is mobile, and entrenched infantry is well protected. But it is the combination of all three into a single weapon system that gives the armored fighting vehicle its unique, indispensable role in the combined arms team. Only they can bring firepower forward under armored protection. The exact kind of firepower, the level of mobility, and the degree of protection depend on the role it is supposed to fulfill. A proper battle tank is traditionally defined as an armored fighting vehicle with tracks for off-road mobility, a turret-mounted main gun for its firepower, and with enough armor to negate shell splinters and rifle-caliber bullets. But that still leaves a lot of room for subtypes. Traditionally, there are light tanks for reconnaissance, medium tanks for exploitation, and heavy tanks for breaking through defenses. During the Second World War, merging some or all of these roles into a single type of universal tank became the preferred choice, as it greatly streamlined production and simplified the tactical application, maintenance, and logistics of large tank fleets. However, placing the British late-war Cromwell tank in the triangle and adjusting the corners for 1944 standards shows a clear bias towards mobility at the cost of protection and firepower. Adding the Challenger brings up the firepower while maintaining the high mobility, but protection remains below the norm. Meanwhile, the British Churchill tank weighs heavily towards protection at the cost of everything else. Explaining this imbalance in British tank design requires a deeper dive into their armoured doctrine leading up to the Second World War. This is a complicated story that involves a lot of different people and even more tank models, so the following overview will keep things focused on the core issue, namely the genesis and evolution of the so-called cruiser tank family that the Cromwell and Challenger were part of. The story starts in 1916 with the introduction of the tank in combat. These were lumbering landships designed for one purpose: support the infantry across no man's land and into the first line of enemy trenches. They had firepower and protection suitable for this mission, but their poor mobility restricted them to the confines of no man's land. Exploiting a breach in the enemy lines and pursuing the broken foe was a role that had belonged to the cavalry for centuries, but improvements in weaponry meant that even a routed enemy could now turn around and mow down charging horsemen. What was needed was another type of tank, one that emphasized mobility, to burst through the breach made by the heavy tanks and rampage through the enemy's rear area like the cavalry used to do. This was the First World War genesis of a split-in-tank doctrine that would dominate global tank design into the Second World War. Heavy, landship-type infantry support tanks to make the initial breakthrough, followed by swarms of mobile cavalry tanks that would pursue the routed enemy. Britain was at the forefront of this next great leap in tank warfare when the war ended in 1918. The ambitious plans that were drawn up for a great mechanized offensive in 1919 using brand new medium tanks never came to fruition, leaving key questions on the decisive use of tanks unanswered for the next 2 decades. The resulting confusion over the future role of tanks paralyzed Britain's armored forces all the way into the Second World War. Despite their initial lead in the Great War, a few key factors worked against British tank development during the peace that followed. The first was that drastic post-war budget cuts, based on a government guideline that no major wars would be fought for the next decade, hit the tank corps especially hard, as it was a junior arm considered by many to be an aberration of trench warfare. With Germany defeated, a return to conventional war on the continent seemed unlikely in the near future, and priority was given to imperial policing. Another issue was that the few visionaries who continued to champion the future role of tanks were often radicals who overstated the capabilities of their machines and ended up turning the more conservative arms against them. This wasn't hard to do, as the British Army had a strong regimental culture of loyalty to one's own arm at the cost of combined arms teamwork. The tankers, who were newcomers and future-minded, were regarded with suspicion by the established arms. Especially the cavalry was determined to mechanize at their own pace, leading to parallel developments that weren't merged until 1939, when the tankers and cavalrymen were combined into the new Royal Armoured Corps. Even when Britain began rearming in the 1930s, the Navy and Air Force received the lion's share, leaving the Army to fight over the scraps, usually with the older arms like the infantry and artillery coming out on top. The tiny budget that was left for mechanization didn't encourage experimentation. Britain's tank industry remained small, and while it continued to develop new models, few of these made any major improvements in their firepower or automotive capability. The actual development chain of British armor was highly confused and inefficient, with individual firms like Vickers being responsible for coming up with their own tank designs that were then presented to a military bureaucracy that had no clear vision of what they wanted. The result was that many tanks were made without explicit direction of what they were supposed to do, followed by endless revision and modification enforced by committees before either being cancelled or entering a limited production run. This inefficiency kept Britain's modern tank fleet small, making it impossible to conduct the sort of large-scale exercises that were needed to stress-test doctrine, meaning many untested theories and assumptions about tank warfare continue to be regarded as facts. So, what was this doctrine that interwar theorists came up with, and what kind of vehicles were designed around it? A returning feature was the division of tanks into specialized roles. While the specifics changed from time to time, the balance that was adopted shortly before the Second World War was as follows. There were light tanks that did reconnaissance. They were not meant to fight, only to scout. Then there were the infantry tanks, who at times overlapped with related concepts like the heavy tanks and assault tanks. In essence, these were heavily armored and slow tanks that assisted the infantry in fighting across no man's land, exactly like the land ships did in the First World War. Protection was their primary concern, mobility was of no concern, and firepower ranged from a single machine gun to small caliber guns. They were organized in independent units that were attached to the infantry for frontal assaults against fortified positions. In between these extremes was a broad class of vehicles known at times as fast tanks, mediums, cavalry tanks, and ultimately cruisers. These were the tanks that the early tank pioneers envisioned for their 1919 offensive to win the First World War. Mobility was their primary feature, as they were to race behind enemy lines in great swarms and overrun headquarters, logistics nodes, and other key infrastructure. Protection was of little concern because they would not engage in frontal assaults. Instead, they relied on the infantry tanks to make a breach in the enemy defenses, or they would simply use their mobility to bypass centers of resistance. When they did have to fight, it was presumed to be against similar types of enemy tanks that were brought forward to stop them. So cruisers were outfitted with dedicated anti-tank guns that could be fired on the move to take full advantage of their mobility. Secondary machine guns, sometimes as many as 3, would deal with enemy supply columns and other soft targets that they would encounter behind enemy lines. Unlike the small packets of infantry tanks, the cruisers were ideally concentrated in large, mobile units, preferably of division size, to give them sufficient mass to sweep deep behind enemy lines like the cavalry used to do. These formations were almost exclusively made up of tanks, with only a small number of supporting arms to accompany them. This was partly a result of the more radical tank theorists who preached the old tank concept, which held that the best way to support a tank was not to include the other arms, but to develop another, more specialized support tank. Actually translating this theoretical software into practical hardware was made difficult by the financial constraints mentioned earlier. Only when serious rearmament began in the mid-1930s did the infantry-cavalry split materialize into designs that would see actual combat. The infantry branch that led to the Matilda and Churchill will not be covered any further. Instead, the focus now shifts to the cruisers as they are about to go through a rapid transformation that will ultimately lead to the Cromwell. The impetus came in 1936 with the adoption of new automotive technology. Most significantly, the American Christie suspension and Liberty engine. Neither of these was particularly new, but their successful integration by the Soviets in their BT series of fast cavalry tanks opened British eyes to the possibility of doing the same for their cruisers. This radical increase in mobility was matched by an upgrade in firepower with the adoption of the 40mm 2-pounder gun. This fast-firing weapon boasted excellent armor penetration for its time and became a hallmark of British tanks in the first years of the war. A new generation of tanks, now officially designated as cruisers, entered production in the late 1930s. Of these, the A30 was the first to incorporate all the new key technology: the Liberty engine, Christie suspension and 2-pounder gun. The increased speed and cross-country performance further solidified the cruiser concept and led to associations with naval warfare. Like their namesakes in the Navy, cruiser tanks were to use speed and firepower to make up for a lack of protection. The German invasion of France in 1940 put these new cruisers to the ultimate test and quickly exposed a number of critical design flaws, mainly that British tanks were unreliable, that the cruisers were poorly protected, and that the 2-pounder was barely adequate. What was needed were new, reliable tanks with better armor and a bigger gun. In essence, a completely new generation of cruiser that was improved across the board. That is not what happened, however. With most British armor destroyed in France, their cities under aerial bombardment, and with a German cross-channel invasion looming, the decision was made to rapidly increase tank production regardless of quality. This led to a number of poorly designed tanks entering mass production without proper trials or even pilot models, made by industrial concerns who had no prior experience building tanks. One of these, the Covenanter, proved so unreliable that it was never approved for combat, while the similar Crusader was used in North Africa for lack of anything better. The Valentine was an awkward hybrid between an infantry tank and a cruiser that combined the worst of both, yet became Britain's most produced tank of the war. Despite their clear technical shortcomings, these tanks were produced in the thousands all the way into 1943. They were put to the test in the deserts of North Africa, and the bloody experience gained there would influence the true next generation of cruiser, the Cromwell. One of the biggest lessons in tank warfare came in 1942, thanks to an influx of American armor that would shake up British tank doctrine for the rest of the war. The United States Army had faced similar difficulties in the interwar era, with a chronic lack of funding, strategic uncertainty, and infighting between infantry and cavalry hampering the development of a battle-ready tank. What the Americans did have was an enormous and flexible industrial base that could quickly adapt to wartime experience. By 1940, they were designing medium tanks that were in a class of their own compared to the small cruisers Britain was desperately mass-producing at the time. When British tankers in North Africa first got their hands on these new American mediums in 1942, it revolutionized the way they approached armored warfare. The biggest change was in firepower, and it's worth discussing this in detail as it will play a crucial part in the development of the Cromwell and Challenger. Firepower is one of the three corners of the tank triangle, and according to many experienced tankers, it's the most important of the three. But whether firepower is good or bad depends as much on the target as on the gun. Broadly speaking, tank guns have two different functions for two different targets. They can fire at other armored vehicles, which requires an anti-tank gun capable of firing a dense, armor-piercing projectile at a very high velocity in a flat trajectory. These penetrate the armor through sheer kinetic energy and enter the tank, incapacitating the crew, damaging components, or setting fire to fuel or ammunition. Achieving armor penetration is more reliant on velocity than caliber, and a high velocity also helps with hitting moving targets. So many early anti-tank guns, like the British 2-pounder, only had a small diameter of around 40 mm, but a comparatively long barrel. This kept the gun compact enough to fit inside a tank, while still achieving sufficient velocity to penetrate the armor of the time. The other function of a tank gun is to act as an artillery piece and fire high explosive shells in an arcing trajectory against soft targets such as entrenched infantry or emplaced heavy weapons like machine guns and anti-tank guns. High explosive shells actually benefit from a lower velocity for a few reasons. The first is that it imparts less stress on the projectile, allowing for a lighter construction and leaving more room for a greater explosive payload. The lobbing trajectory that results from a lower velocity also helps with hitting an entrenched enemy. While a high-velocity shell requires a direct line of sight to the target and must be carefully aimed not to hit short or fly straight over, the arcing trajectory of a low-velocity shell allows it to be dropped down on a position with finer control over the range. Finally, the reduced forward momentum, coupled with the steeper trajectory, results in a greater all-round fragmentation pattern compared to a high-velocity gun that tends to blast a substantial part of its fragments harmlessly into the ground or straight into the air. The same conditions also apply to smoke shells, which are a third ammunition type commonly used by tanks. A problem arises when you want the best of both worlds from the same gun. HE shells, in order to carry a significant payload, need a caliber of 75 mm or more, but propelling a solid AP round of such size to a sufficient armor-piercing velocity requires a stronger propellant charge and a longer barrel, enlarging the overall gun and ammunition to the point that a bigger tank has to be designed around it. The British, in accordance with their cruiser doctrine, made the choice to mount small-caliber, high-velocity guns in their tanks with little regard for HE effect. No explosive shell was developed for the 2-pounder until later in the war, while heavier guns, such as the 6-pounder and 17-pounder, boasted excellent armor penetration but very poor HE effect. To compensate, some cruiser tanks were equipped with large-caliber, low-velocity howitzers and designated close support tanks, but these were mainly used for firing smoke shells and only made up a fraction of the overall tank fleet. This meant that British tanks were woefully under-equipped when it came to attacking soft targets like dug-in anti-tank guns. This became painfully clear in North Africa, where potent German guns like the dreaded 88 could snipe British tanks from afar without fear of retaliation. This changed when the first batches of American M3 Grant and M4 Sherman tanks arrived in 1942. The Americans had taken a different approach to tank armament and decided that a medium-velocity dual-purpose gun with good HE effect was the best choice, even if this came at the cost of armor-piercing performance. These guns were mounted in a new generation of reliable, medium-weight tanks that fulfilled both the infantry support and cavalry pursuit role, making them an early type of universal tank. Backing up these mediums were dedicated tank destroyers mounting higher velocity guns to deal with enemy armor. While this doctrine of specialized tank destroyers was ultimately considered a failure, the dual-purpose tank gun was not, and it gave British tankers precisely the tool they had been missing. Deliveries of the M4 Sherman increased to the point that it became the dominant tank in Commonwealth service, fulfilling both the cruiser and infantry tank roles and blurring the lines between them. British tank development had not been stagnant, however, as efforts were undertaken to get the next generation of cruiser into the field. The specifications for what became the Cromwell were laid down following the defeat in France in 1940. They called for a heavier cruiser tank with armored protection up to 80 mm thick and armed with the 6-pounder anti-tank gun that was still in development at the time. What followed was a long, convoluted and ultimately wasteful development chain typical of Britain's tank industry at the time. On the one hand, the Cromwell had to be based on existing designs to speed up development, while also adhering to strict size and weight limitations imposed by the British railroads. On the other hand, existing tanks like the Covenanter and Crusader were given production priority to make up for the losses in France, pushing Cromwell development to the sideline for multiple years. The predictable result was a tank designed to meet 1940 specifications, remaining stuck in development with little room for improvement until finally seeing action in the summer of 1944. Delving into the Cromwell's complicated design history would be a story on its own, but there are a few key developments worth noting. In short, the Cromwell family consists of three major branches: the A24 Cavalier, A27L Centaur and the A27M Cromwell. The A24 Cavalier was the first iteration of the Cromwell but under a different name. The company that designed it had also produced the Crusader and borrowed heavily from it to decrease development time, including its unreliable automotive systems. While the first prototype was already completed in December 1941, the Cavalier ultimately proved too troublesome and was not approved for combat. The Cromwell was a parallel development carried out by the Birmingham Railway Carriage and Wagon Company. It used the same basic layout as the Cavalier, but made massive improvements to the automotive systems. A key development was the help of Rolls-Royce, who adapted their Merlin aircraft engine for tank use. The Meteor, as it became known, provided an almost excessive 600 horsepower that made the Cromwell one of the fastest tanks of the war. The newfound power of the Meteor led to the much-needed replacement of many automotive parts that had been carried over from the Crusader, including a much more efficient radiator, a strengthened Christie-type suspension, and the new Merritt-Brown transmission. The first prototype was already running by January 1942, but mass production was complicated by competition with the Air Force over the Rolls-Royce engines, which were just as badly needed for Spitfires as they were for Cromwells. This leads to the third offshoot in the Cromwell family, the A27L Centaur, which was essentially a Cromwell fitted with the older Liberty engine to speed up production. This made the Centaur inferior to the Cromwell in the one area where it excelled, namely its mobility. By mid-1944, there were enough Meteor engines to equip all the fighting tanks, and so the Centaur was relegated to support roles, making its production run about as useless as the Cavalier. The Meteor-powered A27M Cromwell was the tank that would see action in 1944. There are a lot more subtypes within the final production model, but these all share the same general characteristics. The standout feature was the mobility, which was the best of any tank in its weight class. A high top speed, both on roads and off, was the most notable, but the sturdy suspension and flexible transmission were also held in high regard. Less well developed was the reverse gear, which was painfully slow, while the narrow tracks gave the Cromwell a fairly high ground pressure and could be thrown off in sharp turns. Protection was another downside. The armor itself was actually quite thick, up to a maximum of 76 mm on the turret front, but most plates were mounted vertically, which greatly decreased their effectiveness. The M4 Sherman and T-34 boasted greater overall protection despite having thinner armor by angling their plates. What did increase protection was the Cromwell's compact design and low profile, which, coupled with its speed, made it a difficult target to hit. This did come at the cost of internal space, which not only affected the crew, but, as we will see with the Challenger, also the ability to upgrade the firepower. Speaking of firepower, the biggest innovation that the Cromwell brought to the table was that it was the first cruiser to mount a dual-purpose gun with good high explosive effect. The original armament was supposed to be the 57mm 6-pounder, which had proven itself in North Africa as a capable tank killer, but its HE shell was described as almost useless. Desert veterans, including the now influential Montgomery, insisted on having a dual-purpose gun like on the American tanks. Thankfully, the 6-pounder mount on the Cromwell could be easily adapted to fit a new British 75mm gun that fired American ammunition with identical performance. The 6-pounder was discarded as tank armament before it saw much use and replaced by the new British 75 on both Cromwells and Churchills. The adoption of dual-purpose guns was an important step in British tank doctrine that led away from the rigidly defined cruiser concept and towards a more balanced universal tank. While the Cromwell was still a cruiser in name, its long design period had molded it into a more versatile medium tank similar to the Sherman, T-34 or Panzer IV, while retaining above-average mobility as its distinguishing feature. The opinions of the people that actually had to fight in the Cromwell differed depending on past experience. Regiments that had only used earlier British cruisers generally saw it as a marked improvement, but those that had fought in Shermans received a bad first impression. The cramped crew stations and narrow hatches made it feel like a death trap compared to the ergonomic Sherman, while the flat, riveted armor plates on the turret seemed like a step back in tank design. However, combat in 1944 revealed that the Sherman was equally under-armored and outgunned, while the Cromwell was at least a faster, smaller target. To quote the regimental history of the 15th 19th Hussars, "While the reliability and general performance of the later Marks were excellent, it is true to say that the Cromwells were out-armored and outgunned by the heavy German Panther and Tiger tanks. This disparity was particularly acute in close country where ranges were short and the power of maneuver restricted, for it was upon their speed and maneuverability, in which respects they were probably the best tanks on the battlefield, that the Cromwells relied for their protection and effectiveness." Perhaps the greatest flaw of the Cromwell was that it was still a 1940 design that had lingered in development until its baptism of fire in 1944. Its mobility was appreciated, but as the regimental history implied, this was more a saving grace than an asset when it's not backed up by competitive firepower and protection. By 1944, the bar for what was still competitive had been raised considerably now that Germany was on the defensive and taking measures to combat the numerical superiority of Allied tanks. Heavier AT guns, man-portable anti-tank launchers, and a new generation of tanks and tank destroyers would be awaiting the Cromwell on the continent. Already in 1943, unsettling reports were coming in about a new German tank that outclassed Allied designs of the time. Before making the final leap from the Cromwell to the Challenger, we must first take a quick detour into German tank doctrine to see why an upgrade in armor-piercing firepower was an absolute necessity. When Germany began rearming in the 1930s, it faced the same dilemmas of tank design that other nations struggled with. Striking a balance between protection, mobility and firepower while using readily available technology that could be quickly mass-produced to catch up with other armies that had been developing tanks for 2 decades. At first sight, Germany's tank philosophy was not too dissimilar from Britain's, sharing a strong emphasis on mobility, the concentration of tanks in mobile formations, specialized close support tanks, and dedicated infantry support vehicles. However, a key difference was in the intended roles of their mobile forces. Whereas Britain's early armored formations were dominated by tanks and acted as the spiritual successor of the cavalry, Germany's armored divisions were mobile combined arms battle groups where the tank was just one part in a diverse toolkit that included mechanized infantry, artillery, engineers, and more. This gave German armored divisions a wider mission set that wasn't limited to the traditional cavalry pursuit role. Consequently, German tanks were more balanced in their design to fulfill this wider range of use. After developing some stopgap light tanks to kickstart production lines, the Germans produced 2 mediums in the late 1930s that they planned to go to war with, the Panzer III and Panzer IV. These were comparable to the cruisers that Britain was developing at the time, but with some key differences, most notably in their firepower. The Panzer III, while equipped with a small caliber AT gun similar to the 2-pounder, was also given high explosive shells to engage soft targets. Meanwhile, the Panzer IV, while equipped with a large caliber low velocity gun like that of the British close support tanks, was given armor-piercing ammunition capable of defeating contemporary tanks. They were also designed from the ground up to be big enough to fit upgrades in armor and firepower, which was something Britain's small cruisers were far more restricted in. At the same time, the German infantry also desired armored support and were given modified assault guns that offered a cheaper form of mobile protected firepower compared to Britain's purpose-built infantry tanks. However, compared to the opposition, Germany's tanks were still lagging behind as a result of the late rearmament. The 37mm of the Panzer III was inadequate against heavier tanks, and its HE shell was only slightly better than nothing. The Panzer IV was more successful owing to its larger caliber, but its tank-killing potential was held back by its extremely low velocity. Both also had inadequate armor protection with lots of inefficient vertical plates. When Germany invaded the Soviet Union in 1941 with these undergunned and under-armored tanks, they were in for a rude awakening when they encountered the T-34. While still only fielded in small numbers, the T-34 raised the bar for tank design by being a versatile medium tank that not only combined good armored protection with excellent mobility and firepower, but also boasted a true dual-purpose gun, firing equally potent HE and AP ammunition, all in a medium-weight package that could be mass-produced by Soviet industry. Meanwhile, to the west, the Americans were also developing their versatile medium tank, the M4 Sherman, that would prove equally challenging when it first appeared. The introduction of these new Allied mediums was a wake-up call for the Germans, who not only found themselves facing superior tanks, but also an ever-increasing quantity of them that they could never hope to match. This was an asymmetric arms race that Germany could not win through production alone. Instead, they needed to achieve a higher kill rate on the enemy by knocking out more of their tanks to offset the production imbalance. This emphasis on tank killing would take on many forms throughout the German armed forces, but for their tank fleet it resulted in two major developments. The first was an improvement in the tank-killing firepower of existing designs by mounting new, high-velocity 75mm guns in them. These could go through the Allied mediums at long range and still had a good HE effect against soft targets. These upgun tanks and assault guns leveled the playing field against Germans and T-34s, but the Germans wanted more than parity. They needed a bigger advantage in quality to offset the numerical superiority of Allied tanks. The second development was the rapid introduction of a new generation of tank that would secure a competitive edge for the coming years. It had to be a balanced design offering mobile protected firepower to the combined arms team, but designed from the ground up to be a generational leap forward, most notably in its tank-killing firepower. The Panther tank that entered mass production in 1943 mostly lived up to these expectations. Anti-tank firepower was excellent thanks to an even higher velocity 75mm gun that could cut through the heaviest Allied armor even at long range. Its HE shell was fired at a significantly lower velocity than the armor-piercing shot, giving it a satisfactory performance against soft targets as well. Protection was a major improvement over earlier German tanks, as the armor was not only thick but also well angled, making the frontal arc practically immune to most Allied guns throughout the war. Equally impressive was that the entire 45-ton package moved around with the speed of a medium tank. The Panther not only had an above-average road speed, but it also boasted excellent cross-country mobility thanks to a stable suspension and low ground pressure owing to the wide tracks and interleaved road wheels. However, the engine and transmission were its Achilles heel, as these were accident-prone and maintenance-heavy, making the Panther not only complicated to produce, but also difficult to keep in service. Beyond these technical shortcomings, the Panther was continually hamstrung by being on the losing side of a total war. The first models were rushed into production and extremely unreliable, while later models used poor quality armor plates. Fuel was always in short supply, and crew training became ever more rudimentary. Production could never keep up with demand, meaning the Panther found itself perpetually outnumbered on all fronts. The Panther was rushed into action on the Eastern Front in the summer of 1943, while the first encounter in the West took place in Italy in early 1944. Its introduction caught the Allies in an unfortunate position, as they were committed to mass-producing their early war medium tanks that the Panther was specifically designed to outperform. M4 Shermans, T-34s and Cromwells didn't have the armor to resist the Panther, nor the guns to take it out frontally. Fielding a next-generation tank that could fight the Panther on equal terms would take time, so the best short-term solution was to increase the firepower of existing medium tanks by mounting heavier guns in them, effectively turning a portion of the tank fleet into stopgap tank killers. Using purpose-built tank destroyers was already an established part of American armor doctrine, but it was still fairly novel to the British, as they had intended their cruisers to also function as their primary tank killers. By this point, the primacy of the 75mm dual-purpose gun was already settled, not only because of its superior HE effect, but also because the British were adopting the American Sherman as their main tank, and these came with the 75 regardless of preference. This was considered fine for the majority of tanks, but it was also recognized that a proportion needed to be armed with something bigger to deal with new threats like the Panther and Tiger. Another demand was that a small number of tanks remain armed with howitzers for smoke laying and high-angle fire, resulting in a three-way split in tank armament. After much debate, the War Office decided in April 1944 on the following triad of tank firepower. A majority of 65% was to be armed with dual-purpose guns, 25% with dedicated AT guns, and the remaining 10% with close support howitzers. This decision was justified as follows. The basis on which these proportions were decided is that recent operational experience has proved that the majority of targets engaged by armor demand the use of HE shell. The anti-tank gun in particular, which forms the most frequently encountered target for tank guns, can most effectively be destroyed by this type of weapon and shell. At the same time, it is essential that every armored unit should possess within its own resources a proportion of weapons capable of dealing with the most heavily armored tanks which the enemy can put into the field. Fortunately, such a gun was already in development and entered service in 1943, the 76.2mm 17-pounder. However, effectively fielding the weapon was made difficult by competing rules. As an anti-tank gun, the 17-pounder fell under the Royal Artillery, who was the first to adopt it in a variety of configurations, including on lightly armored tracked vehicles. While these often used a tank chassis, they were designated self-propelled guns to be used defensively by the Royal Artillery. Meanwhile, the Royal Armoured Corps wanted 17-pounders as main tank guns for use in offensive action, meaning they had to be mounted in an enclosed, fully rotating turret on a well-armored vehicle. However, fitting the massive gun and its ammo within the confines of the available tank models proved difficult. It was easiest on the Sherman, as this tank had room to spare, even if the 17-pounder pushed it to its limits. The resulting Firefly became the most numerous wartime tank mounting the 17-pounder and entered service just in time for D-Day. The Cromwell was a different story, and the difficult conversion process that led to the Challenger will be discussed in detail in the following chapter on design. An alternative solution was not to modify the tank, but to adjust the 17-pounder so it could fit in a smaller turret. The result was the 77mm high-velocity gun mounted in the Comet that saw limited service just before the end of the war. Finally, a universal tank that did away with the rigid division between cruisers and infantry tanks began to be designed in November 1943. The Centurion, as it became known, was built from the start to take the 17-pounder and provided with a level of mobility and protection adequate for the 1944 battlefield. Unfortunately, it did not arrive until 1945, just after the war had ended. The two 17-pounder tanks that would actually see service from Normandy to the end of the war were the Firefly and Challenger. The Firefly supported the more numerous Sherman-equipped regiments and would grow to over 2,000 in number, while the Challenger only entered a limited production run of 200 and was issued to some of the Cromwell-equipped regiments. In the end, the limited doctrinal role the Challenger fulfilled was that of a specialist cruiser tank destroyer that could keep up with the fast Cromwells and protect them against heavy German armor. That concludes the first chapter on Doctrine, the software that shapes the hardware. As a closing remark, it's worth noting that the split between infantry support tanks and cavalry cruisers was not exclusively British, nor was it a bad doctrine. Given the technology of the time, most armies settled on a similar division, using heavy tanks or assault guns for infantry support and medium tanks for use in mobile armored formations. Even the Americans, who did away with the heavy tank and mass-produced a single type of medium, still organized these for different roles. A portion of Shermans were kept in separate battalions for direct infantry support, while the rest were grouped in armored divisions. Where the British doctrine proved mistaken was in the way it envisioned cruisers as modern cavalry acting alone behind enemy lines. The emphasis on speed over armor and pure anti-tank firepower made them ill-prepared against German combined arms formations that supported their tanks with infantry and towed anti-tank guns. Even then, this issue was mostly fixed by the time of the Cromwell thanks to the adoption of dual-purpose guns and reorganization of the armored division into a more balanced combined arms formation. By 1945, the British were outspoken proponents of what they called the capital tank, which Montgomery described as a dual-purpose tank suitable for working with infantry and also for operating in an armored division. As for the design, he prioritized that, having selected the best possible gun as a primary weapon and designed an engine with sufficient horsepower to give the required speed, then armor should be fitted up to the maximum weight allowed. In other words, firepower first, then mobility and finally protection. This need for balance and flexibility in a single type of main battle tank was one of the great lessons of Second World War tank design. However, balance must be maintained as technology advances and the opposition changes. A competitive mix of mobile protected firepower by 1942 standards may no longer be cutting edge in 1944 against newer guns and thicker armor. While it had its flaws, the German Panther did exactly what it was designed for, leaping into the next generation of tank design by improving its mobility, protection and firepower outside the grasp of the previous generation, while still retaining a balance between them. Rushing such an advanced design into production had its downsides, but it did confront the Allies with an opponent they had no true equal to until they started fielding their own next-generation tank in 1945. Instead of equals, they had counters. Weapons like the 17-pounder that had just enough firepower to defeat the newest generation of armor, but had to be carried by the older generation's mobility and protection. Such stopgap upgrades pushed the last generation to its limits, often throwing them out of balance in a desperate bid to improve their firepower above all else. That is what happened to the Cromwell as it was cut apart, weighed down and reassembled into the Challenger. The next chapter on design will detail this process. Having gone through the doctrinal software, the next question is how this translated into the actual hardware of the Challenger. Tank design is an inherently complex process, especially in wartime Britain, where a highly bureaucratic procurement system involved a number of different and often changing boards, departments and committees. For the sake of clarity, this chapter will abstract the procurement process into two parties: the design team, responsible for making the Challenger, and the Army, listing the demands and deciding on adoption. The genesis of the Challenger dates back to the 22nd of August 1941, when the Army first expressed a desire to mount the 17-pounder on a variety of combat vehicles, including a tank of British design with revolving turret. The 17-pounder was still in an early development stage, but from the specifications alone it was clear no tank yet existed that could realistically mount it in a turret. The closest candidate was the Cromwell, being developed at the time by the combined efforts of Rolls-Royce and the Birmingham Railway Company. Sensing an opportunity to leap into the next generation of British battle tank, the design team began modifying their Cromwell to fit the 17-pounder. The Cromwell already showed great promise thanks to its new Meteor engine and other automotive improvements, so the designers tried to incorporate as many of these features as possible, both to retain the excellent mobility and to speed up production time. The one thing they couldn't carry over from the Cromwell was the tiny turret. Luckily, a larger turret for a bigger gun was already designed for the TOG-2, a huge 80-ton breakthrough tank that never entered production, so its turret became available for further development on the Challenger. Making it fit on the narrow Cromwell chassis proved impossible, as the turret required a 177 cm turret ring, while the Cromwell only had room for 152. This necessitated a lengthening of the hull by cutting it in half and adding a 77 cm center section resting on an additional pair of road wheels. Of course, a turret ring needs to be round, not oval, so the hull was not only lengthened but also made wider. This ran into the British railway limit, so instead of widening the track base, a wider superstructure called a turret box was extended over the top of the tracks. This allowed for a larger turret ring without actually making the overall tank wider than the Cromwell. One problem was that this extended superstructure could not carry the full weight of the turret, but this was alleviated through the use of a unique system that mounted the turret on a ball in the floor of the hull. As this carried most of the weight, less stress was put on the turret ring. While this all seems complicated, the design team boasted that the Challenger still shared 90% of its moving parts with the Cromwell, including the powerful Meteor engine, Christie suspension and Merritt-Brown transmission. The specifications were announced to the Army in early May 1942 and the first turretless prototype completed in late July. Mounting a turret would have to wait until the second prototype, as this complicated device was still being fine-tuned for the Challenger. A much bigger problem was the Army's dissatisfaction with the armored protection and consequently doubts about the intended role of the Challenger. The design team had tried to match the Cromwell's level of protection, but the limiting factor was weight, which had to be kept under 31 tons to ensure commonality. Going above this limit necessitated upgrading parts like the suspension, which would turn the Challenger into a tank of its own that no longer shared the majority of its components with the Cromwell. Mounting the big turret with the 17-pounder had already pushed it over the weight limit, so armor had to be made thinner to compensate. The double-layered hull side armor was reduced from a total of 57 mm on the Cromwell to 28 on the Challenger, making it no better than on the last generation of cruisers. The turret, meanwhile, not only gave the tank a high profile uncharacteristic of British tanks, but at 63 mm it also offered less protection than the Cromwell's 76 mm turret face. This was still a decent thickness for the time, but it was less than had been specified for the Cromwell, and this made some experts question the suitability of the Challenger as a battle tank. This was made clear on the 21st of January 1943, when an advisory committee gathered to review the first complete prototype. At this time, the fighting in North Africa against Panzer III and Panzer IV tanks was their main frame of reference, while the Panther had not yet made an appearance and the Tiger was only just being encountered in small numbers. As such, the demand for armor-piercing firepower wasn't as strong as it would be a year later, and the Challenger was regarded as a bit of a curiosity. Most critical was Lieutenant Colonel Turner, Chief Instructor of the Gunnery Wing, who saw the Challenger's only advantage at extreme ranges beyond 2.5 kilometers, where it could use its 17-pounder outside the effective range of the Panzer IV's upgraded 75mm gun. He argued that this could have been useful in the open desert, but in Europe the ranges would be shorter and its comparatively thin armor made the Challenger vulnerable to return fire. Turner also considered the Cromwell already superior to the Panzer IV at these European ranges and therefore saw no need for the Challenger. In the end, the committee did recognize the need for tank destroyers, but only as specialist vehicles that would accompany armored units on a similar scale as anti-aircraft and close support tanks. They did accept Turner's argument that these vehicles needed competitive armor, as their role would put them directly in the line of fire. And as the Challenger was too thinly armored, it should only be produced as a stopgap until a tank of equivalent protection to the Cromwell or Sherman could be upgunned. This essentially relegated the Challenger to the role of self-propelled gun, despite being designed as a battle tank and having all the features of one. In February 1943, following the advice of the committee, an order was placed for a limited production run of 200 Challengers. This was the decision that doomed it to forever be a stopgap with no hope of mass production. While this wasn't the role the designers had hoped for, it should at least have given them the honor of making the first 17-pounder tank to see combat. But this wasn't to be either. There were still a lot of issues to fix and tests to run before serial production could commence. Meanwhile, the design team had started up-armoring the Challenger in hopes of still getting it approved as a tank in a class of its own. The Challenger prototype still had plenty of horsepower, so by September 1943 they were welding on additional armor plates and making plans for a Stage 2 redesign, which would essentially be a completely new tank designated as the A30. The suspension proved to be the limiting factor, however, and the design never made it beyond the drawing board. Meanwhile, the actual Challenger could barely resist 2-pounder shots with its turret armor during firing trials in November 1943. The testing revealed unacceptable weak spots, and the subsequent redesign further pushed back the start of production into 1944. Among the necessary improvements was a fully welded turret, a stronger internal mantlet, and a protective strip to prevent splinters from jamming the turret ring. The suspension, meanwhile, struggled under the increased weight, while the complicated electrical turret reverse system needed continual refinement. It wasn't until April 1944 that this stopgap tank from 1942 was advanced enough to go through its acceptance trial, which it promptly failed due to reliability issues. By now, the need for 17-pounder tanks was so urgent, however, that the Challenger was still accepted for service, as the problems were minor and hopefully fixed on the final models. Production started slowly, and by the end of June 1944, with the Allies struggling to break out of their Normandy beachhead in the face of heavy German armor, just 34 Challengers had been produced, of which 5 were deemed substandard. Only in August did enough Challengers finally become available to equip the first frontline units. Even by this late stage, modifications were still being introduced on the production line. From the 41st Challenger onward, a thicker cast turret nose was fitted that improved armor to 102 mm. Then in October 1944, the last 100 Challengers had 1.5 tons of additional armor welded to their front. As these were being produced, the unforeseen use of wider tracks caused issues with the idler wheel when reversing in mud. This was considered enough of a problem that the Challenger was no longer deemed battle-worthy and withdrawn from combat in November until a modification was made. By the end of 1944, only 145 Challengers were delivered of the 200 that had been agreed upon in early 1943. This increased to 192 at the end of the war, meaning the stopgap tank destroyer from 1942 hadn't even completed its limited production run before the war was over. While the mass production of Sherman Fireflies and the eventual introduction of the Comet made up for the shortfall, the premature condemnation of the Challenger as a stopgap self-propelled gun, followed by unnecessary delays in production, prevented it from becoming the successful battle tank that it could have been. In its final form, the Challenger was faster than the Sherman, of similar protection as the Comet, and with a gun matching that of the Panther. It was well liked by its users, and there was even a time during the Normandy campaign that Montgomery suggested a full replacement of all Cromwells by the Challenger, before being told by the War Office that it was a mere stopgap and he should wait until 1945 to get the new Comets. That covers the history, but what about the end result? The following part will use the three corners of the tank triangle, mobility, protection, and firepower, to explore the technical characteristics of the Challenger and how these impacted its combat performance. Starting with mobility, this was largely the same as the Cromwell, meaning it was excellent. Both vehicles boasted the same 600 horsepower Meteor engine, Christie suspension, and Merritt Brown transmission, with the only major automotive difference being that the Challenger had one more suspension unit for a sixth road wheel to carry the longer hull. There was also a weight increase, with the final production model, including crew, fuel, and ammo, weighing in at a little over 32 tons compared to the Cromwell's 28. Coupled with a different final drive ratio, this made the Challenger slower by about 8 km per hour on roads. It was, however, faster and more stable off-road thanks to its longer track base and strengthened suspension. Lengthening the tracks without setting them further apart can result in steering difficulties, but this wasn't noted as a major issue for the Challenger. The suspension gave the most trouble, which was to be expected, but in the end this was improved to the point that the final production models could even be up-armored beyond the original weight limit. The biggest mechanical flaw that revealed itself during active service was the front-mounted idler wheel jamming with mud when reversing, but this was more a result of the unforeseen use of wider tracks than an inherent design flaw, and it was quickly fixed with some minor modifications. Overall, the Challenger had its share of mechanical issues during its development, but the final models were on par with the Cromwell when it came to mobility and reliability. Moving on to protection, this was the most controversial part of the Challenger and what ultimately held it back from wider adoption. The whole armor layout was similar to that of the Cromwell, with both using thicker vertical plates and thinner sloped plates that started with a riveted construction but were eventually welded on the later models. On both tanks, the driver's visor plate was the thickest piece at 64 mm, but was mounted vertically, which reduced the overall effectiveness. The biggest downgrade on the Challenger was the side armor thickness, which was reduced by half to stay within the initial weight limit. The lengthened hull and turret box also made the Challenger a slightly larger target, although the additional surfaces that made up the turret box were of the same thickness as the Cromwell's equivalent plates. The turret was the biggest weak spot by far, being a larger target with less armor. On the Cromwell, the turret face was the thickest part of the entire tank at 76 mm, but on the Challenger it was only 63. The turret sides, meanwhile, were 64 mm on the Cromwell, but just 40 mm on the Challenger. On both tanks, the turret plates were mounted vertically, which limited their potential. Both also used an internal mantlet that necessitated gaps in the front turret plate to make room for the main gun, coax machine gun, and gunner optics. Overall, the difference in protection wasn't huge, and by the time both tanks first saw action in mid-1944, there were plenty of German guns capable of piercing them at long range. Belated up-armoring started with the 41st Challenger that rolled off the production line sometime in July 1944 and replaced the 63mm turret nose with a thicker cast plate of 102mm. Then, in October, the last 100 Challengers were given 25mm of additional armor plating on the vertical surfaces of the frontal arc. Of course, the effectiveness of these additional plates was still limited by the vertical arrangement, but this was inherent in the design and a necessary trade-off to save internal space. The extra armor didn't help much against the most powerful guns of the time, but it did give the Challenger a degree of immunity against older guns at longer ranges, as testing revealed that the up-armored frontal arc could now resist 6-pounder shots beyond 550 meters. Besides keeping enemy projectiles out, another facet of protection is minimizing the damage of those that do make it through the armor. This is harder to put into numbers as there are a lot of different variables at play. One obvious downside of the Challenger was the relatively large turret. As this is the part of the tank that has to be exposed in order to fire, it is also the most likely to get hit in return. Unlike the Cromwell's 3-man turret, the Challenger had 4 crewmen out of 5 in the turret, which was cramped as a result. Whereas the Cromwell stored all of its ammo low in the hull, the Challenger had multiple ammunition bins spread throughout the turret basket for faster loading. All this meant that the part of the tank most likely to get hit also had the least amount of protection and highest concentration of things you didn't want to get hit. As for escape options, there were hatches for all crew members except for the gunner, who shared a roof hatch with the left side loader. Like most British tanks of the time, the gunner had a smoke grenade launcher that fired in a fixed arc towards the front of the turret and could be used to create a protective smokescreen. Finally, the best protection is not getting hit in the first place. In this regard, the Challenger's tall profile made it a larger target than the Cromwell, although it was still slightly smaller overall than the Sherman. Its good cross-country mobility also made it a difficult target to hit when moving, especially at longer ranges. Camouflage netting was typically used to break up the outline, and for this special mounting brackets were installed as a field modification. There were also attempts to hide the fact that some tanks, in particular the Sherman Firefly, carried the 17-pounder by painting the end of the barrel to make it look shorter. While this was also done for some Challengers, the larger turret still made it easy to recognize. The third, final, and arguably most important feature is firepower. This is a combination of the gun, the ammunition it fires, the way it is mounted, and how it is directed on target. When the 17-pounder was designed in 1941, it was primarily intended as a field-mounted gun to be used by the Royal Artillery. As such, it was large and heavy, and little attention was paid to the trouble of fitting it inside a tank turret. When the Challenger's design team took up this task, they were given the Mark II version, which was only a minor modification of the 17-pounder for use in self-propelled mounts. The more space-efficient Mark IV was eventually developed for the Sherman Firefly, but never installed on the Challenger. The 17-pounder's singular design purpose of punching holes in armor plate made it very good at this, although its accuracy, especially at longer ranges, was considered disappointing even under ideal circumstances. In actual combat, accuracy suffered for different reasons. The inherent difficulty of identifying an enemy tank at long range was not helped by the gun sight that only offered 3 times magnification. Once fired, observing the fall of the shot and adjusting for the next one was made difficult by the sheer power of the 17-pounder, especially inside a cramped tank turret. The recoil disorientated the gunner, and the large muzzle flash kicked up a great cloud of dust, which, coupled with the noise, was especially hard on the commander, who was typically observing through binoculars with his head outside the turret. It also drew the enemy's attention, so it was vitally important to make the first shot count before quickly changing position. Just as important as the gun is the ammunition it fires, and in this regard the 17-pounder had a mixed reputation. Like most AT guns of the time, its ammunition evolved from standard armor-piercing to armor-piercing capped and eventually armor-piercing capped ballistic capped. Of these, APC-BC offered the best overall performance by adding a hollow ballistic cap to the tip of the projectile. This slightly increased the overall length, leading to issues on the Challenger as its interior dimensions were designed for the shorter APC cartridges. This meant that some bins could not store the longer APC-BC rounds, and worst of all, they could not be loaded into the gun if this was depressed below 2 degrees. Firing APC-BC already made the 17-pounder the most powerful AT gun in the British arsenal, but there was one more ammunition type that pushed it above and beyond its competitors: the armor-piercing discarding sabot, or APDS. Sabot ammunition achieves a very high velocity and penetration by using a subcaliber projectile, meaning it's smaller than the diameter of the gun that fires it. The small projectile is propelled through the barrel by a full-caliber sabot, essentially a casing that holds the projectile in place but falls apart outside the confines of the barrel, leaving the subcaliber projectile to fly off on its own at a very high velocity. Upon striking armor, the tungsten carbide projectile concentrates its tremendous kinetic energy on a very small surface area, giving it one of the highest armor penetration values of all Second World War ammunition. While great in theory, APDS fired from the 17-pounder proved troublesome and was still in an experimental stage by the time of the Normandy landings. The first batch was shipped over in July, but field testing revealed them to be inaccurate and inconsistent against sloped surfaces like the Panther's front plate. As late as November 1944, APDS ammunition was still undergoing trials before being accepted for operational use. Only by early 1945 was APDS more readily available at the front, even though it was still plagued by accuracy issues beyond 900 meters. The 17-pounder's high explosive shell was also held back from its full potential. Unlike the 2-pounder and 6-pounder, the diameter of the 17-pounder was big enough to allow for a decent HE shell, but a fixation on armor-piercing firepower sidelined its development. Not only were HE shells produced in smaller numbers, but the initial model was given the same high velocity as the AP ammo, meaning its explosive effect was extremely poor. This became a major issue in Normandy, as it was clear that the 17-pounder had to be introduced in larger numbers to deal with German armor, but at the same time could not become the sole tank armament, as its explosive effect was far inferior to that of the 75mm. The very simple step of reducing the propellant was adopted as a stopgap and first entered service in late 1944. The lower velocity offered a slight improvement in explosive effect, but led to problems with the fuses not activating. For the Challenger specifically, the older Mark II 17-pounder could not eject the reduced charge casings, so it was decided that the Challengers would use up the existing stock of high-velocity and low-capacity ammo, while the Fireflies got the new rounds. It wasn't until 1945 that the so-called super high-capacity HE round entered production, which gave the 17-pounder a low-velocity, high-capacity HE shell with adjustable fuse, finally turning it into the dual-purpose gun it could have been from the start. Despite these downsides, the gun was still the best part of the Challenger. It was the difficulty of mounting it in a turret that caused the most trouble. The fundamental problem was that the turret was not designed for the 17-pounder nor for the Cromwell, but to mount a 3-inch anti-aircraft gun on the cancelled TOG-2 Super Heavy tank. While this had the benefit of providing the Challenger with a ready-made turret large enough to fit the 17-pounder, it did carry over some strange design choices. While large on the outside, the interior was cramped due to the inefficient mounting of the main gun. This followed the British design preference for a balanced gun, meaning a significant part of the weapon, as well as the protective mantlet, were mounted inside the turret and taking up valuable space. The 17-pounder was also placed higher than originally intended to comply with the demand for all-round 10 degrees of gun depression. Because the hull of the Challenger was made longer, it extended into the gun's field of fire when it was fully depressed to the rear, so the gun had to be placed higher in the turret in order to fire over its own extended hull. Another odd choice was the inclusion of 2 loaders. There had been continual disagreement over the necessity of the second loader, with the final ruling being that he wasn't needed and even got in the way. But by that point the interior layout had already been finalized and the position was kept. While there was no objective need for him, the second loader did have some benefits. For one, the loader also acted as a radio operator in British tanks, so with 2 men, one could prioritize the radio while the other focused on loading. Another benefit was that one loader could stay with the gun while the other replenished the ready racks from harder-to-reach ammunition bins. Finally, 2 loaders working in turns could achieve a high rate of fire of 1 round every 6 seconds. Sustaining this rate was of course dependent on the accessibility of the ammunition. While the Challenger only carried a meager total of 46 rounds, 14 of these were easily accessible at all times because they were kept in 5 bins that rotated along with the turret basket. Another 14 were spread around the fighting compartment but outside the basket, while the remaining 18 were stored in the front of the hull on what used to be the hull gunner seat on the Cromwell. For comparison, the Sherman Firefly carried an impressive total of 78 rounds, but only had 5 of them readily accessible for its single loader. Aiming and firing was done by the gunner who was seated left of the breech. Besides his number 43 gun sight, he also had a rotating periscope for a wider field of view. Gun elevation was controlled with a handwheel from -10 degrees to +20 degrees. Traversing was done through a novel electrical system. While this came with a lot of teething troubles and took up quite a bit of internal space, it proved to be one of the most popular features of the Challenger, allowing for precise laying and lightning-quick traverse. Its performance was linked to the engine RPM, with a maximum traverse rate of 30 degrees per second at 2700 RPM, giving it one of the fastest tank turret rotations of its time. Besides the main gun, the gunner also fired the Browning M1919 coaxial machine gun. This American weapon was a unique addition to an otherwise British tank, as these typically used the Besa machine gun. However, the Besa was a bulky weapon that took up internal space that the Challenger didn't have, so the Browning was a necessary replacement that came at the cost of an additional ammunition type to the supply chain. The Browning was mounted to the right of the breech where the commander was seated, which not only cramped his position and choked him with fumes, but also burdened him with the reloading and maintenance of the weapon. When closed down, the commander's vision was restricted to a fixed front and rear periscope on a rotating cupola. This offered very little situational awareness and gave the commander no other option than to stay opened up, even in combat, leading to a high casualty rate. The commander's hatches locked open in a vertical position and could be used as an armor plate when opened up or as a rest for his binoculars. Finally, there's the matter of directing a tank's firepower on target, and for this the Challenger had a number 19 wireless set located in the back of the turret. The number 19 was a popular radio that could be found in most wartime British tanks. It featured a 3-in-1 functionality, providing intercom between all crew members, a short-range fixed-frequency net for the troop level, and a long-range net that connected all tanks within a regiment. It was operated by one of the loaders who dialed in the frequencies, while the commander had a small control box to switch between the nets. Listing a tank's technical features doesn't say much in isolation. Mobility, and especially firepower and protection, only become meaningful when compared to the opposition. While it wasn't the most common threat, the German Panther tank offers an interesting comparison because it was precisely the kind of heavily armored target the Challenger was designed to deal with. The following comparison will have the Cromwell and Challenger face the Panther, to illustrate both the shortcomings of the Cromwell and the necessity of the Challenger. The comparison will be limited to those technical features that impacted their tactical use. It will not include operational or strategic factors such as fuel consumption and reliability, although it should be noted that these generally favored the British tanks. In other words, the machines will be judged on their potential in battle, not the long road from the factory to the battlefield. Starting with mobility, this was the traditional strong point of British cruiser tanks, although the Panther wasn't far behind. The Challenger was a bit slower than the Cromwell, reaching 50 km per hour on road compared to the Cromwell 60 km per hour, with both averaging around 30 km per hour off-road. The Panther managed a 45 km per hour max road speed and a cross-country average of 20 km per hour. This made the Panther slower overall, although it's worth keeping in mind its weight class, with the Panther coming in at 45 tons compared to the Challenger's 32 and Cromwell's 28. Despite being substantially heavier, the Panther actually had a lower ground pressure thanks to its wide tracks and interleaved road wheels, allowing it to cross soft ground that the narrow-tracked British tanks were liable to get stuck in. An unusual feature common to both sides was that they could neutral steer, allowing the tanks to pivot in place by simultaneously moving one track forward and the other backward. However, whereas the steering system on the Cromwell family was generally regarded as one of its strong points, it was a notorious source of breakdowns on the Panther. The reverse speed on all three vehicles was poor, as they only had one reverse gear that didn't go beyond walking pace. All things considered, the Cromwell and Challenger had an overall speed and mobility advantage, but the Panther wasn't lagging far enough behind to make this a decisive factor, especially not on a tactical level where movements were typically limited to small bounds from cover to cover. Much more impactful was the firepower in relation to the armored protection. The Panther was designed from the ground up with tank-killing firepower as its strongest feature. Its 75mm gun fired a 6.8 kg APC-BC shell with explosive filler at a muzzle velocity of 935 meters a second, giving it a theoretical armor penetration of 168 millimeters against a vertical plate at a distance of 500 meters. Even greater penetration could be achieved by its potent but rare APCR tungsten core ammunition. This wasn't needed for the Cromwell or Challenger because both could be pierced by the regular APC-BC shell out to extreme ranges of 3 kilometers. The Cromwell had the thickest armor on its turret front, but this was still vulnerable within 2.5 kilometers, even when struck at a 30-degree side angle. The original Challenger with its 63mm turret face didn't stand much of a chance at any range. As neither the Cromwell nor the Challenger could rely on their armor to save them from a direct hit, it was all the more important to take out the Panther before it could fire, but this was made difficult by its excellent frontal protection. The biggest obstacle was the 80mm thick upper front plate angled back at 55 degrees, which gave it a head-on line-of-sight thickness of around 140mm. The lower front plate was significantly weaker at 50mm angled back at 55 degrees, but was harder to hit. The turret front was mostly covered by a curving mantlet that presented an awkward target. Its weakest point was in the middle of the curve where the armor was vertical, but this was still an imposing 100mm. This armor layout made the Panther's frontal arc immune to the 75mm gun of the Cromwell, as its 680 meter a second muzzle velocity gave its 6.8 kg projectile a theoretical penetration of just 84mm at 500 meters. It wasn't completely hopeless, as there were a few tricks the Cromwell could fall back on, but these will be shown in the chapter on tactics. The Challenger's 17-pounder performed much better, firing a 7.7 kg APC-BC shot at a muzzle velocity of 884 meters a second, which gave it a theoretical penetration of 163 millimeters at 500 meters. This put it on par with the Panther's gun, but unlike its opponent, the Challenger needed every single millimeter to count. On paper, it would have to snipe two very specific weak points to have a chance of making it through the front. The mantlet, if struck perfectly in its flat center, could be pierced at all ranges, while the lower front plate only became a weak spot within 400 meters. But the biggest target, the thick and angled upper front plate, proved troublesome at all ranges. A report on the first captured Panther, published in May 1944, judged the plate to be nominally immune to 17-pounder APC-BC, meaning Britain's best AT gun still wasn't enough to level the playing field. However, actual firing trials carried out against captured Panthers showed that its armor was weaker than anticipated, the front plate especially proving brittle and prone to cracking. The main culprit was Germany's shortage of key resources, in particular the chemical element molybdenum, which decreased the effectiveness of their armor plate by as much as 20%. Extensive firing trials were carried out in late 1944 that revealed the upper front plate to be vulnerable to 17-pounder APC-BC within a kilometer. One round went clean through the armor, while the others deformed the plate, cracking the armor, bulging the inside, and spraying the crew compartment with metal splinters. These splinters, called spalling or flaking, were caused by the brittle nature of the armor that cracked under pressure instead of absorbing the blow, meaning a shot did not even have to penetrate for it to injure the crew. While it took until early 1945 for these official findings to be published, British tankers were already conducting their own firing trials in Normandy and came to the same conclusion. The 33rd Armoured Brigade shot a captured Panther with a Firefly at short range with devastating effect. All shots penetrated fully or partially and caused severe cracking and spalling. As expected, the lower front plate and mantlet were the weakest parts of the frontal arc. Then there was Britain's secret wonder weapon, 17-pounder APDS ammunition. While the projectile was lighter at 3.6 kilograms, its tremendous muzzle velocity of 1200 meters a second gave it a theoretical armor penetration of 256 millimeters at 500 meters. This was enough to pierce the Panther's upper front plate even at its best quality, while testing revealed that the subpar armor plate could be cracked as far out as 1300 meters. What all this meant in practice was that shooting a Panther was a bit of a gamble for the crew of a Challenger. Sniping a weak spot was difficult given the poor optics and accuracy issues, while piercing the large upper front plate depended on invisible production defects. Even then, a poor quality Panther could still bounce a shot if it stood on sloping ground or presented a small side angle. APDS gave a bit more certainty, but had its own issues with accuracy and ricochets. This specific example ties into the broader point that armor-piercing ballistics don't translate well into binary yes or no answers. In other words, no shot is guaranteed to penetrate, no matter how powerful the gun, nor is a weak gun entirely incapable of doing damage. There are just too many variables at play, from the weather to armor quality, ammunition type and impact angle. Especially in real-world conditions, shots tend to strike at odd angles as vehicles stand on uneven ground or move unexpectedly, or shots may pass through an obstruction like a tree or a wall or ricochet from a strong armor plate into a weaker one. Even if a shot pierces the armor, it often deforms and loses much of its velocity by the time it gets inside the tank, so the actual damage of a penetrating hit can differ drastically. It may fall harmlessly into the tank, it may decapitate the driver and take the gunner's leg off, or it may hit ammo and instantly blow the tank apart. On the other hand, a shot that doesn't fully penetrate can still injure the crew through spalling, or its impact may disable optics, radios, tracks or the turret traverse, or simply panic the crew to the point that they bail out. So what we are left with are not certainties but probabilities. The Challenger 17-pounder could take out a Panther frontally, depending on the range, the ammunition, where it hit, armor defects, and other variables. It wasn't guaranteed, but it had a decent chance, and it was more than the Cromwell could hope for. Speaking of the Cromwell, its only real option was to find an angle on the Panther's thinner side armor. The superstructure was a decent 50 mm thick, but only at a slight angle of 30 degrees. The lower hull, partially hidden behind the road wheels, was 40 mm and vertical, while the turret side armor was 45 mm and nearly vertical. This meant that even the Cromwell's gun could go through the lower hull and turret from well over a kilometer and the superstructure within 400 meters. Scoring a penetrating side shot had a high chance of hitting one of the Panther's many ammo racks or the volatile petrol and cause a catastrophic fire. Actually getting on the flank of a Panther is of course a lot easier said than done. The Cromwell's mobility and low profile gave it an edge over the Sherman in this regard, but the Panther was neither blind nor slow. The commander had an excellent all-round vision cupola that allowed him to observe in all directions, even when close down. When in danger of getting outflanked, the Panther could pivot in place by neutral steering and quickly face its front to the emerging threat. Its turret reverse, like that of the Challenger, was tied to the engine RPM. When idling, it wasn't that impressive, but if the driver revved up the engine, it reached a competitive 20 degrees per second. A notable downside was that the crew periscopes were fixed in place, unlike the British that could pivot and rotate for a wider field of view. The Panther's gunner didn't even have a periscope, meaning he saw the world through his narrow gun sight. While this was an excellent tool for long-range gunnery, it restricted his field of view to the direction of the turret, and he had to be carefully guided on target by the commander. The loader, meanwhile, had an impressive 82 rounds to work with, but these were spread throughout the tank with only 10 being within easy reach. All this meant that the Panther was often slower to acquire targets, slower to reload, and slower to react, especially to unexpected threats from the side. It was strongest when facing targets frontally, at long range and with secured flanks. In that case, only the 17-pounder had a chance of going through, and even then this required good gunnery and a fair bit of luck. In hindsight, the Challenger is now mostly known as the awkward-looking stopgap that was only produced in limited numbers before being surpassed by the Firefly and Comet, themselves also being temporary stops on the long road towards the Centurion. Yet at the time, there was a brief moment where it could have been more. The Challenger wasn't destined to be an emergency tank destroyer, but was forced into this role by unfortunate circumstances. The bureaucratic, committee-based nature of British tank procurement lacked long-term vision, and at the time of the Challenger's inception was still preoccupied with mass-producing simple cruisers. This put the Challenger in an especially bad spot, as it was designed too early for its own good. While the 17-pounder proved to be an absolute necessity in 1944, it was massive overkill in 1942 when the Challenger was built around it. Another problem was the competition it faced. Throughout its development, the Challenger was held back by promises that an improved high-velocity gun could still be mounted in the original Cromwell turret. When this was proven false, the Comet was presented as the next step in cruiser design, while in the meantime, the Sherman offered an easier way to quickly field 17-pounders, leaving the Challenger to fall by the wayside. But perhaps the root cause that ultimately held back the Challenger was an identity crisis. While developed as the next generation of battle tank, doubts about its protection and the 17-pounder's single armor-piercing purpose pushed the Challenger into the more limited role of self-propelled anti-tank gun. This uncertainty persisted when it entered frontline service, as war diaries and regimental histories refer to it as both a 17-pounder tank and self-propelled gun. The entire argument was then turned on its head by its late-up armoring, which ended up giving it a superior level of protection to the Cromwell. Another point of confusion was the generation the Challenger belonged to. While it ended up as a Super Cromwell similar to how the Firefly was an upgun Sherman, the designers had always hoped to develop it into a tank of its own, but this ultimately ran into chassis limitations that had been introduced as far back as the Cavalier and the fateful decision to base it on the Crusader. Just as the Germans had reached the limit of their Panzer IV and had to start anew with the Panther, so the British had to accept the limits of the Cromwell and begin work on the Centurion from the ground up. In the end, the Challenger remained shackled to the body of a 1940 tank pushed to its absolute limits. While the final design possessed an impressive balance of mobility, protection and firepower, the time and effort it had taken to get there had relegated the Challenger to a support role by the time it finally saw action. Having gone over the hardware, the next two chapters will look back to software to explain how this stopgap tank was actually used in combat. When the design of something doesn't make clear what role it is supposed to fulfill, the answer can usually be found by looking at the way it is organized for battle. But with British late-war cruiser tanks, this only raises more questions. One bit of certainty is that Challengers were always grouped with Cromwells, but the problem is that the Cromwell was no longer the dominant tank in Commonwealth service by 1944. The widespread adoption of the American Sherman had blurred the once so rigid lines between Britain's tank classes. The Sherman, being a balanced universal tank, now dominated both the Armoured Division, that was once the home of the cruiser, as well as the independent tank brigades that housed the infantry support tanks. This left the Cromwell in an awkward spot, as it offered little over the Sherman except for increased mobility, but without improving armor or firepower. By 1944, the Cromwell had found three uses in Commonwealth armoured divisions. The first was none at all, as the divisions that served in Italy, as well as the Canadians in Western Europe, exclusively used the Sherman. The second was full adoption as the main fighting tank, which was only done by the 7th Armoured Division, the famous Desert Rats, who fielded a total of 4 Cromwell-equipped regiments. Then there was the specialized use of Cromwells in the division's Armoured Reconnaissance Regiment, resulting in 1 regiment of Cromwells alongside 3 of Shermans, which is how the remaining armoured divisions in the European theatre distributed their tanks. So, while technically not a cruiser, the Sherman had taken over this role in the majority of Commonwealth armoured divisions. On the other hand, the Cromwell had grown into a versatile medium tank and could do similar work as shown by the Desert Rats. The Cromwell's role in the other divisions was also a lot more versatile than its place in the Armoured Reconnaissance Regiment may imply. By 1944, the accepted practice for armoured divisions was to split into combined arms brigade groups, typically of 2 tank regiments and 2 infantry regiments. As there were only 3 Sherman regiments and 4 of the infantry, the Cromwell regiment was usually mixed into one of these brigade groups and used as a regular tank unit. So in the end, the Cromwell and Sherman were largely interchangeable despite the difference in mobility. An armoured division could be full of Cromwells or full of Shermans or a mix of both and still function practically the same. What neither of them could do was slug it out with heavy German armour. So the next question is how tank destroyers like the Challenger were organized. On the divisional level, the distribution of 17-pounders was split between the Royal Artillery and Armoured Corps. The highest concentration could be found in the Royal Artillery's anti-tank regiment, which fielded 17-pounders in both towed and self-propelled configurations. While the latter shared a lot of similarities with a tank, they were not used as such, as the anti-tank regiment fulfilled a mostly defensive role by waiting in reserve and securing ground that had been taken by the offensive units. Speaking of offensive units, the other place 17-pounders could be found was directly embedded in the tank regiments of the Royal Armoured Corps. The Sherman-equipped units received Fireflies, while the Cromwell units should have received Challengers. However, their slow production made it impossible to equip everyone in time. When the British Second Army landed in Normandy, it fielded 3 armoured divisions for a total of 6 Cromwell-equipped regiments, leading to a demand for 72 Challengers, but less than 30 had been produced by that time. The decision was made that the 3 Armoured Reconnaissance Regiments would have top priority, while the 3 regular armoured regiments of the 7th Armoured Division would get Sherman Fireflies instead. This wasn't ideal, as the Sherman was taller and slower than the Cromwell, but it was certainly better than having no 17-pounders at all. This meant that most Challengers could be found in the 3 Armoured Reconnaissance Regiments of the British Second Army, these being the 15th 19th Hussars in the 11th Armoured, the 8th Hussars in the 7th Armoured, and the 2nd Welsh Guards in the Guards Armoured Division. However, there are accounts of Challengers showing up in regular Cromwell units, while some of the recce regiments had to replace their losses with Fireflies in late 1944. The Polish Armoured Division and the Czechoslovakian Brigade also used Challengers alongside their Cromwells, but only received them near the end of the war. Taking a closer look at the Armoured Reconnaissance Regiment gives better insight into how the Challenger was actually used in combat. As noted earlier, a regiment like this is actually a battalion-sized unit, while its company-sized subunits are called squadrons and the platoons are called troops. The regiment had 3 fighting units, known as Sabre Squadrons, labeled A, B and C Squadron, supported by an HQ Squadron. One very important unit within HQ Squadron was the Reconnaissance Troop, sometimes called a Reconnaissance Squadron. They utilized small 2-man scout cars of the Humber and Daimler type, although some regiments fielded American-made light tanks instead. The majority of HQ Squadron was concerned with the vital work of supply, maintenance, repair, signals and medical care. Transport was organized in 2 groups called echelons. B Echelon operated at the regimental level and brought in supplies from further in the rear, as well as housing the more senior mechanics and specialists. A Echelon formed the crucial link from the regiment down to its Sabre Squadrons and brought forward petrol, ammunition and rations, as well as doing first-line repair and recovery work. A Echelon was typically split into smaller squadron-level support columns that closely followed the tanks. The squadrons themselves all shared the same organization of a headquarters and 4 troops. The squadron was typically commanded by a major with a captain as his second-in-command. The major had a regular Cromwell, while the captain and squadron sergeant major had close support versions with the 95mm howitzer. These still had smoke laying as their primary purpose, although they could also fire a heavy HE shell against fortified positions and a hollow charge anti-tank round in self-defense. Rounding out the HQ was an armored recovery Cromwell for towing away immobilized tanks. The smallest tactical units were the 4 troops that made up each squadron. A troop consisted of 4 tanks led by a lieutenant assisted by a troop sergeant. 3 of the tanks were regular Cromwells and the 4th was a Challenger. It was important to have an experienced leader in command of the Challenger, but not the lieutenant or troop sergeant, as these already had their hands full commanding both their own tanks and the troop as a whole, and were often at the front of the formation where a Challenger made for an easy target. This meant that Challengers were usually commanded by a sergeant who was expected to take the initiative in support of his troop. This dispersed organization meant that every troop, the smallest unit in the regiment, had 1 17-pounder gun under direct control. From the German perspective, this meant that wherever there were British tanks, there was at least 1 17-pounder nearby. This allocation was also in accordance with the War Office policy that 25% of tanks should be equipped with the best possible AT gun, while the 2 close support Cromwells at Squadron HQ fulfilled the demand for 10% howitzer tanks. The official policy wasn't popular everywhere, as some tankers argued for grouping all 12 of the 17-pounders into their own squadron at the regimental level. These could then be kept in reserve and deployed in concentration when and where they were most needed. Some units picked a middle ground and grouped their 17-pounders into special tank hunting troops at the squadron level, but the standard practice that was followed most of the time was to integrate the 17-pounders down at the troop level. This ensured the greatest degree of protection against sudden enemy armor, while balancing out the Challenger's poor anti-personnel performance with 3 dual-purpose Cromwells. Especially the long and unwieldy barrel and the lack of a whole machine gun were considered important reasons to keep the Challenger at the back of the troop until needed. Another benefit of troop-level integration was the high degree of trust and teamwork that existed down at the lowest level. Not only did the men of a troop live together, but they almost always fought together as a single cohesive unit, leading to a familiarity with each other's tactics, techniques, and procedures. An experienced troop had ingrained battle drills that were carried out automatically without needing detailed orders over the radio. Making the Challenger a trusted member of this team greatly increased its effectiveness. A flexible tank allows for a flexible organization. If every tank is equally capable, then it doesn't really matter how troops and squadrons are organized. But when specialized rules are introduced, getting the right tank to the right place at the right time becomes vitally important. Britain's split in tank armament had the predictable result of encumbering their armored organization, with every troop being reliant on a single vehicle for their anti-tank defense, yet also being burdened by its lack of versatility. But despite its downsides, dispersion was still preferred over concentration when it came to mobile tank warfare. The next chapter on tactics will show why. British tank tactics had gone through considerable changes by 1944. The cruisers in particular had started the war emulating cavalry tactics as prescribed by pre-war doctrine, leading to costly charges over open ground reminiscent of the Crimean War and the infamous Charge of the Light Brigade. Their equipment was partly to blame, as the 2-pounders had a short effective range and the lack of HE shells forced them to charge AT guns to get within machine gun range or simply run them over. The open deserts of North Africa proved an important learning ground that forced British tankers to adapt their tactics, moving away from trying to fight naval battles on land and instead making better use of terrain, firing from cover, and alternating fire and movement instead of the old emphasis on firing while moving. Already in 1941, a training pamphlet for cruiser tank troops defined successful tank-on-tank action as bringing the enemy to battle by the skillful use of mobility, ground, and surprise fire. The use of ground was particularly important, the manual stressing that individual tanks should find suitable firing positions behind hills, in woods or among buildings, and to switch between positions using covered routes. Movement in contact with the enemy was done through fire and maneuver, with some tanks going firm in a stationary overwatch position while other tanks bounded forward to the next train feature, then alternating again and again. Fighting from hull-down positions was ideal, as these only exposed the tank's smaller turret in order to fire while keeping the larger hull behind cover, and also allowing for quick and safe repositioning by reversing into a full turret-down position. Carefully picking your ground was especially important when facing enemy armor, the manual stating that tank combats are won by fire, and greater accuracy of fire is obtained from a stationary tank. The troop leader's object must be, therefore, to deploy his tanks so that they can bring surprise fire to bear from stationary concealed positions. This will entail skillful use of ground and rapid movement between selected positions. However, these tactics were developed when armor-piercing firepower still largely favored the British, But by 1944, the tables had turned, with Germany introducing heavier armor, just as the British adopted weaker, dual-purpose guns backed up by a handful of tank destroyers. Developing tactics for this new balance of firepower was something tank crews had to do in the field, as 70-pounder tanks were introduced only just in time for D-Day and opportunities for training were extremely limited. Reconstructing the improvised tactics, techniques and procedures they came up with is difficult, as this differed by unit and was constantly evolving. Going through war diaries, regimental histories and memoirs shows that the fundamental principles of tank warfare still held true, but the application was less flexible now that only 1 in 4 tanks could reliably deal with enemy armor. Some of the best tactical insight can be gained from Firefly veterans. The first thing to note is that, despite the 17-pounder's mixed performance, they were confident in its ability to deal with German tanks head-on. Lieutenant Render from the Sherwood Rangers considered the Firefly the technical antidote to the Tiger and Panther's advantage in protection, while Lieutenant Hills, who served in the same regiment, said that if a German Panther or Tiger tank turned up, we just had to whistle up a Firefly. Sherman troop leader Lieutenant Render goes over his tactics in more detail. On bounding Overwatch, he writes that he used to split his troop in 2 pairs, the rear element including the Firefly. I advanced first in aim under the static cover of Corporal Lane's tank and would go firm a tactical bound ahead of him. His tank would then join mine, and we then repeated the process, with Harrison bringing up the rear with the Firefly. The same applied when attacking a position. To quote, "Using the cover of the bank, we would then advance line abreast and blast out the German infantry from the dugouts with HE and machine gun fire. Archer and the Sherman Firefly would hang back and cover us from the forward edge of the American lines." Another option was to leave the Firefly in position and make a bound with 3 tanks. Quoting Render again, "I left the Firefly in an Overwatch position and the rest of the troop followed me as we broke through some trees and headed towards the citadel." Alternatively, multiple Fireflies could work together. Sergeant Wardrop, himself a Firefly commander, noted how 2 of his colleagues knocked out 5 tanks. To quote, "While one fired, the other would hang back a bit a short distance to a flank. The first one would then reverse and the second pull forward and fire, and then the trick was repeated." Lieutenant Render also shares some interesting tricks for dealing with a Panther using the Sherman's 75mm gun, which was functionally identical to the one on the Cromwell. One option was to fire an AP round at the lower part of the sloping mantlet to ricochet it into the fin hull roof and either kill the driver or hit the ammunition bin right behind him. While this involved a fair bit of luck, it was successfully replicated during firing trials against captured Panthers, and the Germans eventually introduced a flat lower mantlet to stop it from happening. Render, however, had little faith in the weak AP shot and found high explosive to be more reliable, writing that a heavier German tank could be disabled by smothering it with a sufficient weight of HE fire to smash optics and damage its tracks. He also states the explosion could force splinters through the Panther's fin roof armor with lethal results. This possibility was indeed pointed out in the Department of Tank Design's report on the firing trials against captured Panthers, noting that the brittleness of the roof plate suggests, however, that a round of 75mm or 25-pounder HE detonated low on the mantlet would probably blow a hole in the roof and displace hashes. An after-action report by the 24th Lancers, who had fought Panthers in Normandy, noted similar results, including that, on the occasion when heavily shelled by HE from our 75mm guns, the crews were seen to bill out, and also that HE seems to have the effect of blinding the crew and forcing the tank to move, possibly thereby exposing its more sensitive sides. Another option was to fire a white phosphorus smoke shell, either to blind the Panther and make it move, or to hit it directly and panic the crew into thinking they had caught fire. This led to a battle drill where, upon encountering a Panther head-on, the 75mm tanks would immediately open up with HE, aiming for the turret face or tracks, and leverage their superior rate of fire to keep the German crew stunned, while the 17-pounder tank rolled up to pierce the armor with an AP round and knock it out for good. As for the Challenger specifically, an example of one responding to presumed enemy armor is given by the 15th 19th Hussars when they ran into a German blocking position on the road southeast of Liesel, a small village in the Netherlands. This action took place on the 24th of September, just 4 days after their battle against German Panthers at Somme that will feature in the second part of this video. A squadron's fur troop under Lieutenant Egerton was spearheading the advance down the road when its lead Cromwell was hit by an AP round, caught fire, and the crew bailed out. Seeing the hold-up, 4th Troop under Lieutenant Ireland flanked east of the road to help out, but a large-caliber gun had them covered. It aimed high, however, and struck the lieutenant in the head, killing him instantly but leaving his tank unharmed. Having lost their commander to an unidentified high-velocity gun, 4th Troop quickly turned around and fell back. This left Egerton's fur troop stuck on the road, with the fields to his left covered by enemy fire, a hedgerow-lined creek blocking his right, and his knocked-out lead tank obstructing the road ahead. Instead of withdrawing, Egerton decided to fight it out, and this is where his Challenger came in. As usual, it had followed at the rear of the troop, but now Egerton spotted a worthwhile target. To quote his military cross recommendation, "One gun to his front, owing to its camouflage, was thought to be a tank, and the Challenger was brought forward to deal with this, as it was impossible to get at it except from the front. The only position this tank could bring fire onto it was from behind a high hedge, where it could not observe directly. Lieutenant Egerton therefore observed for it himself from a position where he was in view of the enemy gun. After firing 1 or 2 rounds, the Challenger received a direct hit from another enemy gun, which penetrated the turret and killed 2 of the crew. Egerton continued the battle with his own tank, but with half his troop gone, he was unable to advance. The fighting died down and the enemy withdrew during the night, leaving behind 3 knocked-out 88mm guns. The misidentification of the 88 as an enemy tank makes this an interesting example, as it gives insight into the troop battle drill when encountering enemy armor. The Challenger was brought forward to deal with this, as it was impossible to get at it except from the front, reveals that Cromwells avoided head-on engagements with tanks if at all possible, and instead marked out a target for the Challenger to deal with. That this was easier said than done is made clear by the fact that only one suitable firing position could be found, from which the Challenger could not even observe its own shots. Despite being fully obstructed behind the hedgerow, the Challenger only fired once or twice before an unseen 88 had zeroed in on its massive muzzle flash. That the turret was hit is not surprising given its tall profile, and neither the front of 63 nor the sides of 40mm could stand up to an 88. While 2 out of 4 men in the cramped turret were killed by the projectile, the Challenger didn't catch fire and managed to retreat, eventually being put in for repair. At first sight, this case redeems the misgivings about the Challenger's protection back in 1943. It was, indeed, unable to resist return fire at European ranges that its role as a tank destroyer would inevitably expose it to. However, it should be noted that neither a Firefly or Comet nor the up-armored Challenger would have fared much better against a close-range 88. The case also demonstrates that mobility is only as good as the terrain allows. Out on the main road, Egerton's Challenger was funneled by constricted terrain and overlapping fields of enemy fire into a single predictable firing position behind the dubious protection of a hedgerow. However, on the more open left flank, the shot that decapitated Lieutenant Ireland had missed his low-profile Cromwell, and his troop quickly escaped the enemy field of fire without further casualties. So, while there is evidence that the Cromwell and Challenger could use their mobility as a form of protection, This did require room for maneuver that wasn't always available in Western Europe. As for firepower, there was no enemy armor for the Challenger to engage, and it's unclear if it contributed to the 3 knocked-out 88s or if this was done by the superior HE fire of the Cromwells. This specific example reflects more general tactical difficulties that were also encountered by Sherman-equipped units. The fundamental issue was that the 1 in 4 troop configuration lacked the flexibility to deal with enemy armor in the crucial first seconds. All things being equal, the tank that spots first, shoots first and penetrates first tends to win the engagement. But because the tank that spots the enemy first will almost always be one of the 75s, it then leads to a complex battle drill where the 17-pounder must be brought forward, costing precious time that may hand the initiative to the enemy. Another maxim of tank tactics is that stationary tanks destroy moving tanks, so the act of having to move the 17-pounder out of reserve and into a firing position greatly increases its vulnerability, which isn't helped by the fact that neither Challenger nor Firefly had the armor to save them. Then there is the issue that enemy tanks rarely fought alone. While a Commonwealth troop only had one 17-pounder, the German platoon equivalent fielded between 3 and 5 Panthers, meaning the Challenger could not expose itself to fire at one without retaliation from the rest. The Challenger's tall profile and large muzzle flash certainly didn't make this any easier. So, while the 17-pounder added some much-needed punch to the troop, it was no simple solution to the Panther problem. Both Sherman and Cromwell units needed to be extremely careful and adhere to the principles of tank tactics. Use strain to your advantage, engage a moving tank with a stationary tank, employ coordinated surprise fire, and seek out the enemy's flanks. Especially the last point was the key to success, as most Panthers ended up being killed from the side by guns that had no chance of going through their front. That concludes part 1 on theory. From this broad range of topics, 4 points stand out that are worth reflecting on. The first is the key importance of flexible firepower. While the Second World War showed a general trend towards balanced, multi-role tanks formalized post-war as main battle tanks, the one feature that really couldn't be compromised on was firepower. While mobility was important to get the firepower in position and protection necessary to shield it against certain threats, it was ultimately the main gun that defined the tank, and if a tank was upgraded, it was usually the firepower that received top priority. What defines good tank firepower mainly comes down to flexibility. It needs a good high explosive shell to deal with the majority of soft targets, but also the ability to reliably pierce the armor of opposing tanks. What defined British tank guns for most of the war was that they were purpose-built anti-tank weapons with poor HE ammunition, whereas other countries often based their tank armament on air defense guns or field artillery pieces that came with decent HE shells. Combat experience quickly reviewed this shortcoming and led to the adoption of American 75mm dual-purpose guns, but these were lagging behind in armor penetration even before the Germans introduced their heavier tanks, raising the question if a gun is still dual-purpose if it can no longer reliably pierce enemy armor. The British fielded the powerful 17-pounder to compensate, and while its performance with APDS easily made it one of the best AT guns of its time, an overemphasis on armor penetration again led to a poorly designed HE shell that held it back from also being an excellent dual-purpose gun. The takeaway here is that the word firepower doesn't say much on its own, but always has to be defined in relation to the target. The Challenger and Cromwell had both great and poor firepower depending on the target they shot at. The second point is that overly restrictive size limits shorten a tank's competitive service life. While certain constraints on the weight and dimensions of a tank are sensible or even necessary, these will end up limiting the competitive lifespan of the design as they leave no room for upgrades. The most successful and longest-serving tanks of the Second World War were those that were built big enough to grow, especially in regards to firepower. This put British tanks in a particularly bad spot, as they were kept narrow for rail transport and low profile for tactical reasons, meaning they were just big enough to mount the gun they were designed for. This shackled British tank service life to that of their gun, whereas larger tanks could remain competitive after a firepower upgrade. When the British let go of these limitations in 1943, they designed the Centurion, which started out with the 17-pounder, but ended up mounting a powerful 105mm gun that kept it competitive for decades. As a stopgap, mounting the 17-pounder on the small Cromwell only proved possible by ripping it apart and reassembling it into the Challenger, whereas the larger Sherman was converted into the Firefly through a relatively minor turret rearrangement, while also carrying an additional 32 rounds. The takeaway here is that firepower is tied to size. For a dual-purpose gun to fire both effective HE and AP, it has to be big. Mounting it in a fully rotating turret with enough room for the crew requires a large turret ring, meaning the hull also has to be made bigger, and at that point you're essentially making a new tank. As the Challenger showed, there comes a point where modifying an existing chassis is more trouble than it's worth, and you better start new. The third point is on the tactical consequences of divergent firepower. The failure to develop a competitive dual-purpose gun in time for the Normandy landings led the British to adopt an awkward triad of tank firepower. A majority of 75mm guns, backed up by a quarter of 17-pounder AT guns, and a small amount of close support howitzers. While the 75mm were good enough for most targets, the ever-present danger of heavy German armor forced close integration of the bigger guns. While concentration may have made sense on paper, the constricted European battlefields and quick pace of armored warfare meant that troop-level dispersion was ultimately the wiser choice. This came at the cost of flexibility, however, as the junior officers in command of tank troops had to constantly balance the strengths and weaknesses of two different weapons under stressful, unclear and quickly changing circumstances. Instead of a straightforward kill chain where the tank that spots enemy armor can also take it out, or where equally capable tanks can cover each other against multiple threats, the British troop had to perform a conspicuous and time-consuming shuffle to get the 17-pounder in position, where it then made for a singular high-value target. It was certainly better than nothing, and most troop commanders made the best of a bad situation, but it goes to show that simply fielding a weapon isn't enough. Tactics, battle drills and a flexible organization must be developed to make the most of it, especially when availability is limited. Finally, it should be recognized that the opposition was tough. The 1944 battlefield was a very unfriendly place for tanks, and some of the best tank-killing weapons could be found in the German arsenal, including mines, man-portable launchers, and powerful guns both towed and self-propelled. Especially the Panther tank was regarded as a dangerous foe by many Allied tankers, and for good reason. While it had reliability issues, was limited by its weight and fuel consumption, and never produced in sufficient numbers, it did confront the Allies with a leap in mobile protected firepower that they had no true equal to until 1945. They did have stopgap counters like the Challenger, and through combined arms tactics, operational maneuver and overwhelming strategic pressure, they ultimately negated many of the Panther's strongpoints. How this worked out on a micro level in an actual battle between Challengers and Panthers will be the subject of part 2.
To see a Challenger tank in action, we will have to travel up the road from here to the villages of Son and Nederwetten, because it was there that on the 20th of September 1944 a tank battle took place between Cromwell tanks and Challenger tank destroyers of the 15th 19th Hussars, and facing them Panther tanks of the German 107th Armoured Brigade. Precisely the kind of target the Challengers were designed to go up against.
In the relatively brief period that the small batch of Challengers served in combat, the battle for Somme on the 20th of September stands out as their finest hour. Thankfully, the details of this engagement have been preserved by a number of sources that allow for a thorough reconstruction to be made. Prime among these is the unusually detailed war diary of the 15th-19th Hussars, complemented by their equally thorough regimental history. Backing this up is the wealth of material that has been written on Operation Market Garden and the 101st Airborne Division that they fought alongside. Some of the civilians that were caught in the battle have also left their recollections as well as photographs of the ensuing wreckage. Even on the German side, where detailed primary sources are usually scarce, the war diary of the opposing tank battalion has survived and is supplemented by a post-war study into the brigade's combat performance. The final source is the landscape itself, which has remained remarkably well preserved in most places. The structure of Part 2 is as follows. First, some necessary background information will be provided, including an operational overview, order of battle for both sides, analysis of key terrain, and summary of the important opening moves on the preceding day. All this lays the groundwork for the detailed reconstruction that follows. The battle begins on the morning of the 20th with the defense of the Somme Bridge by B and C squadrons. Then, at midday, the action moves slightly to the southeast as Captain Weatherby of A Squadron leads his small force on a daring counterattack at the village of Nederwetten. Taken together, these two actions provide a full day of fighting to be examined in the final conclusion. For the ground forces tasked with the garden part of Operation Market Garden, the plan was fairly straightforward. Punch a hole through the German lines with overwhelming firepower, then exploit this with mobile units. The breach would be made by British 30 Corps at the Dutch-Belgian border, and their drive would end on the shore of the IJsselmeer Lake, cutting off all German forces to their west in the Netherlands and setting up British forces for follow-up operations to the east into Germany. Speed was of the essence, but it was feared the Germans could fatally slow down the operation by blowing the numerous bridges along the route, so the decision was made to use airborne forces to capture these key bridges, in effect rolling out an airborne carpet for the ground forces to advance over. The mission of the 15th-19th Hussars within the larger operation was twofold. First, they were detached from their parent division, the 11th Armoured, where they served as the Armoured Reconnaissance Regiment, and given to 30 Corps to assist them in breaching the German defenses along the Dutch-Belgian border on day 1 and 2 of the operation. Then on day 3, they would move up the corridor and come under command of the American 101st Airborne Division to help them defend their long and narrow sector that stretched from Eindhoven in the south to Veghel in the north. In the meantime, 8 Corps with the rest of the 11th Armoured Division was advancing to the east of 30 Corps, but at a slower rate, as they didn't have the benefit of airborne forces clearing their way. Once 8 Corps came up level with the eastern flank of the 101st, the Hussars would revert back to the 11th Armoured Division and join the 8 Corps advance to the east. Besides the Hussars, the Sherman-equipped 44th Royal Tank Regiment would also be protecting the 101st, giving this airborne division a temporary tank strength of 2 armoured battalions, matching that of many German Panzer divisions by this point in the war. It should be noted that nothing about this mission was particularly well suited for a cruiser-equipped Armoured Reconnaissance Regiment, as they would mostly be serving as infantry support, first for the British in an attack on prepared positions, and then for the Americans in a very shallow defense. This reinforces the point made in Part 1 that Britain's cruiser doctrine had largely made way for a more general use of tanks as part of a combined arms team, and that this new rule applied equally to both Sherman and Cromwell-equipped units. The 15th-19th Hussars, as the name implies, was a merger of two earlier cavalry regiments. They had exchanged their horses for armor in 1938 and took part in the 1940 Battle of France as a lightly equipped mechanized divisional cavalry regiment. The Hussars were hit hard by Germany's lightning campaign and forced to retreat through Dunkirk with the loss of their equipment. Upon return to Britain, the Hussars spent a short time as a motor machine gun regiment before being converted to a cruiser-equipped armored regiment in the 9th Armoured Division, where they would stay from late 1940 up to D-Day. The light tanks they had lost in France were replaced with Covenanter cruiser tanks that were barely an improvement, but in March 1943 the Hussars were one of the first units to receive the new Centaur. During this time, the manpower of the regiment was constantly changing as new recruits came in for training before being sent on to units fighting overseas. But the most promising recruits were kept by the regiment, giving it an above-average standard of training and technical expertise. With D-Day looming in May 1944, the Hussars were fully equipped with the latest Cromwells and eager to go into action. But just as the invasion was about to be launched, they were told to leave their Cromwells behind and undergo training in amphibious Sherman tanks. As the battle for the Normandy beachhead raged, the Hussars went through a hasty conversion course into a so-called water assault regiment. They had only just completed their training in August when they were once again told to hand in their tanks, only this time they were to pick up the new ones at the front. In the chaotic 3 days that followed, the regiment was shipped to France, placed under the 11th Armoured Division and once again outfitted with Cromwells. On the evening of the 15th of August, in an orchard near Bayeux, the Hussars collected the machines they would fight and perhaps die in. Among the familiar Cromwells stood 12 strange new vehicles with tall turrets and long guns. The Challenger was completely new to the Hussars, and so was its armament, as the regimental history makes no mention of ever training with the 17-pounder back in Britain. The men were given 2 days to familiarize themselves with their new machines before going into battle. After years of preparation, the regiment finally went into action on the 19th of August. By this point, the German forces in Normandy had been ground down and beaten back into the Falaise pocket, leaving the door wide open for a pursuit deep into France and beyond. With the enemy front shattered and open country stretching as far as the German border, British cruiser Doctrine experienced a brief revival as armored forces raced ahead of their supporting units, overrunning routed German troops and bypassing isolated strongpoints. The Hussars made the most of their speedy Cromwells and Challengers as they raced through France and into Belgium as flank guard for the 11th Armoured Division, spearheading the 30 Corps advance. They gained valuable combat experience along the way, both in the combined arms battle, but also by fighting on their own. The occasional encounter with a Panther tank was reported, but the only confirmed armored kills were on self-propelled guns. This experience did come at a price, as mines, AT guns and launchers took their inevitable toll, but the non-combat losses were minimal thanks to the excellent reliability of the Cromwell. This Great Swan, as the British called their breakout into France, came to an end in early September as supplies ran out and German resistance stiffened along the Dutch-Belgian border. On the 12th of September, the Hussars were shuffled into position for Market Garden, and on the 17th the operation was launched. When they faced the German Panthers at Somme 3 days later, the Hussars had the following forces available to them. As shown in Part 1, an Armoured Reconnaissance Regiment had a paper organization of 3 Sabre squadrons supported by a headquarters squadron. Commanding the 15th 19th Hussars was Lieutenant Colonel Taylor. As this may cause confusion with the commander of the 101st Airborne Division, who was also called Taylor, it's important to distinguish between the British Colonel Taylor of the Hussars and the American General Taylor of the Airborne. Assisting Colonel Taylor was the regiment's second-in-command, Major Bolmain. A squadron was commanded by Major Pearson. Special mention must be made of Captain Weatherby, who was the squadron's second-in-command, and Lieutenant Egerton, who commanded 3rd Troop, as these men will play a big part in the coming battle. A squadron's losses had been comparatively light so far. Worst hit was the 1st Troop, whose leader was killed on the 14th of September. As this troop is not mentioned during the battle on the 20th, they were likely held in reserve or merged with the other troops. A squadron's heaviest losses were suffered by its supply echelon, who were caught in a German bombing raid on the 19th, costing 5 vehicles and 3 men. B Squadron was led by Major Ralph Donnell. The 10th of September was a dark day for them with heavy losses in men and machines. On the 20th, they were down to just 8 tanks, organized in 1st and 3rd Troop and a small HQ element. C Squadron was under the command of Major Courage. They reported only 1 operational loss by September 12th, but their luck ran out in the opening days of Market Garden when they suffered 4 vehicles destroyed and 1 damaged with multiple fatalities. During the tank battle on the 20th, only its 3rd and 4th Troop are mentioned. The Recce Squadron had also suffered losses, including its commanding officer who was wounded in an ambush, leaving Lieutenant Butler in command. They had been trained on American light tanks, but were given scout cars instead, as these were better suited for the reconnaissance role. The overall losses had reduced B and C squadrons to half their allotted strength, while the stronger A squadron split up into 2 smaller groupings to cover more ground, the end result being that the Hussars would fight their tank battle not as 3 Sabre squadrons, but as 4 smaller half squadrons, each about as strong as 2 tank troops and including at least 1 Challenger to protect against heavier German armor. Besides the losses, there were also reinforcements. A squadron of the Royal Dragoons was assigned to the Hussars for Operation Market Garden. Called the Royals for short, they were an armored car regiment specialized in corps-level reconnaissance. Each of its 4 squadrons was capable of independent action through the combined use of armored cars, scout cars and dismounted scouts. While the Royals served a reconnaissance role similar to the Hussars' own Recce squadron, their Daimler and Staghound armored cars were much better armed and armored than the light, open-topped scout cars of the Hussars. Adding some heavy firepower was 341 Battery of the 86th Field Regiment Royal Artillery. They operated 8 Sexton self-propelled 25-pounders capable of direct and indirect fire. Once the regiment came under command of the 101st Airborne, arrangements would be made for American infantry to accompany the tanks, rounding out the Hussars to a fully fledged combined arms force by the 3rd day of Market Garden. On the 19th of September, their opponent also entered the stage. Of the many reinforcements that the German High Command was racing to the Market Garden sector, the 107th Panzer Brigade under Major von Maltzahn was one of the most impressive, boasting more than 2,000 men, 36 Panther tanks, 11 Jagdpanzer tank destroyers, and over 150 half-tracks. While sometimes described as pocket panzer divisions, this misses the true purpose of these late-war armored brigades. Germany's panzer divisions were fully fledged combined arms formations that possessed all the necessary tools for violently breaking through and then rapidly exploding behind enemy lines. The late-war Panzerbrigaden were smaller brigades with a much more limited scope. While tactically offensive, as all armored formations are, their operational and strategic role was actually defensive. They were to act as a mobile reserve that lay in wait behind the front line to counterattack enemy breakthroughs. An instruction pamphlet on the correct use of armored brigades sums it up as follows. Its purpose is to conduct mobile warfare to destroy enemy break-ins or breakthroughs either through immediate counterthrusts or deliberate counterattacks. In other words, the mounted attack with a limited goal. This narrow scope was reflected in the brigade's streamlined organization of 2 parts, a tank battalion and a mechanized infantry battalion. The principal weapon of the tank battalion were its 36 Panther tanks, fielded in 3 companies of 11 tanks each, organized in 3 platoons of 3 tanks, plus a 2-tank HQ element. Supplementing the 3 tank companies was a 4th company equipped with Jagdpanzer tank destroyers. These boasted armor and firepower equal to the Panther, but lacked the flexibility of a rotating turret, instead relying on a lower profile to serve a more passive ambush role. The brigade's other half was the Panzergrenadier Battalion, mechanized infantry riding in armored half-tracks and lavishly equipped with firepower. Many of the dismounted infantrymen carried cutting-edge assault rifles, while their half-tracks came with an assortment of heavy weapons, ranging from autocannons to mortars and close support guns. Backing them up was an assault pioneer company including flame-throwing half-tracks. Besides these direct combat forces, the brigade also possessed reconnaissance, air defense, command and control and sustainment echelons. Taken together, Germany's new Panzerbrigaden possessed a high degree of armored protection, off-road mobility and lots of firepower, especially anti-tank firepower. While small in size, they were intended to punch above their weight through speed, surprise and superior machines. However, beneath the impressive paper organization were some serious drawbacks. The tank battalion was deliberately downsized to deal with Germany's critical tank shortage. While the tanks and armored infantry still possessed plenty of direct firepower, the indirect fire of the artillery arm was omitted to make the brigades more mobile and decrease supply demands. The 107th was supposed to receive some half-track mounted rocket artillery, but these were never delivered, leaving it reliant on mortars as its only source of indirect fire. Yet, even without artillery, the brigade still had massive supply demands, as being fully tracked and armored required lots of fuel and maintenance. Logistics weren't made any easier by the wide variety of weapons, including tank guns, 2 types of mortar, infantry support guns, special ammo for the new assault rifles, and no less than 3 different calibers of flak cannon. The brigade's transport echelon of just 20 trucks, with a total capacity of 60 tons, was woefully inadequate for any kind of sustained action, with the limited amount of reserve fuel being especially restrictive. The brigade's short reach was further limited by a lack of bridging equipment, a serious shortcoming for a unit whose main striking force consisted of 45-ton Panther tanks. While the Assault Pioneer Company had a few bridge layer half-tracks, these could only carry themselves and not the Panthers. This lack of bridging was made worse by inadequate reconnaissance troops, especially the complete absence of armored cars, which meant the brigade commander could not receive timely information on water obstacles and the availability of crossing points. All these drawbacks illustrate the limited scope of Germany's late-war armored brigades. They were primarily a streamlined defensive tool to be used for quick counter-thrusts over familiar terrain and in cooperation with frontline units that would furnish the brigade with additional support it did not have organically. Unfortunately for the 107th, its combat deployment to the Market Garden sector fell well outside its intended use. Things were already off to a bad start with a brief training period. Not only was the brigade scrounged together in 6 weeks, but the actual training time was even shorter as the first Panthers arrived in late August and were mostly used for company-level exercises, with only 1 full-scale brigade exercise being held before being sent to the front. The actual deployment was another major issue as it was piecemeal and very chaotic. The brigade was trained close to the Eastern Front, but was sent west by rail on the 16th of September to reinforce the German border near Aachen. Just as it was underway, the Allies launched Market Garden and the brigade was rerouted to the Netherlands instead, the first trainloads arriving early on the 18th at railheads in Venlo and Roermond, both about 50 kilometers east of the Allied offensive. German High Command was still scrambling to make sense of the situation, leading to unclear or even impossible orders being given to von Maltzahn. His brigade was placed under command of the 86th Army Corps and ordered to immediately head to Eindhoven to block the advance of British 30 Corps, which was still south of the city by this time. This was clearly impossible, as most trains hadn't even arrived yet, and the ones that did took time to unload. So von Maltzan pleaded his case and was given until the morning of the 19th to assemble his forces. But by this time, the Allied armor and airborne had linked up at Eindhoven, and so his objective was shifted north to the bridge at Somme. When the deadline was reached the next morning, parts of the brigade were still being unloaded and crucial fuel reserves were missing, leading to a piecemeal deployment. The sources differ on the exact units that were available by this point, but either way, they also had to secure their own flanks as they advanced into enemy territory, meaning that only a fraction of the already limited forces could be concentrated for the main effort at Somme. Counting the Panthers that were identified by the Allies during the ensuing battle, 6 confirmed kills and 4 probable sightings give a total of 10 tanks, which is almost a full company. The German sources place elements of the 2nd Company at Somme on the 19th, which makes them the likely opponent of the Hussars, while the other companies were either still unloading, out on the flanks, or didn't make their presence known during the battle. Just as likely is that a composite force from different companies was deployed, as a single train could not carry a full company's worth of Panthers. The best piece of evidence would be the tactical markings painted on the tanks, but unfortunately these are all burnt away on the available photographs. One other unit present at the battle was the 1st Battalion of Fallschirmjäger Ersatz- und Ausbildungsregiment Greve under command of Hauptmann Vosshagen. This was a recently formed training unit of German paratroopers, but only around 30% had actually received parachute training. The remainder were recruits scraped from Luftwaffe ground personnel. It boasted 4 rifle companies with plenty of automatic small arms, but possessed no heavy weapons, and the troops were poorly trained and motivated. The battlefield where the Panthers and Challengers clashed is shown clearly on this American aerial photo from May 1944, which is facing to the east. The relevant area fits in a triangle between Helmond, Somme and Eindhoven, with the crossroads village of Nuenen at its center. The Allied corridor to Arnhem runs between Eindhoven and Somme in the foreground, while in the distance German-occupied Helmond can be seen. The area in between was mostly uncontested until the German brigade arrived. As is typical of the Netherlands, there are no notable elevation differences, but there are lots of water obstacles, both natural and man-made. Highlighting just the major ones shows that the area is boxed in by the Wilhelmina Canal to the north, Zuid-Willemsvaart to the east, Eindhoven's Canal to the south, and the Dommel Creek to the west. While there are plenty of roads that connect all the villages, these only cross the major water obstacles at a few points. Examining the train from the German perspective shows just how restricted they were. By the late afternoon of the 19th, von Maltzan had led his available forces out of Helmond, through Nuenen, and established his forward headquarters in Nederwetten. His objective, the Somme Bridge, was just a stone's throw away, but blocking a direct strike was the winding Dommel Creek that formed a natural flank guard for the Allied corridor as it ran from Eindhoven to Somme. There it intersected with the Wilhelmina Canal that blocked any movement north. These waterways could not be forded, the brigade had no adequate bridging equipment, and existing crossing points were few and far between. All minor bridges over the Wilhelmina Canal had been blown by the Germans in the days preceding Market Garden, including the bridge connecting Breugel with Nederwetten, which would have been von Maltzan's best route north. The main bridge at Somme was also destroyed, but had just been replaced by an Allied Bailey bridge. Over at the junction of the canal and the Dommel, a sturdy culvert provided the only route west and onto the Allied corridor. Just one other crossing point over the Dommel was nearby, but this was a small footbridge near the Hooijdonk watermill, incapable of carrying any sort of vehicle. No other bridges spanned the Dommel for 3 kilometers until the road between Eindhoven and Nederwetten crossed it at Soeterbeek. Von Maltzahn had ordered his scouts to check it out, but what they encountered was a rickety structure only rated for 8 tons, and seeing as their mission was no longer Eindhoven but Sonn, this bridge was of little use to them. This left the Germans with just one bad option. If they wanted to get their tanks into Sonn, they would have to cross the Dommel by going over the narrow, exposed southern canal bank, then pivot north and take the Bailey Bridge. The only choices now left to von Maltzahn were when and with what. On the same afternoon as the Germans were planning their opening move, the Hussars also arrived in the area. At 10 o'clock in the morning, they entered Eindhoven and slowly made their way through jubilant crowds welcoming their liberators. A Squadron and the Royal Dragoons remained in the city under command of the American 506th Regiment, while the rest of the Hussars moved up the road to Sonn, where they reported to General Taylor in his divisional command post. Taylor's biggest concern at the time was to the west, where the stubbornly defended village of Best formed a staging area for German counterattacks against his drop zones. A big glider serial with much-needed reinforcements would come in at 1500 hours, so Taylor wanted the Germans driven back. B and C squadrons fought a battle that lasted until sundown and came at the cost of 2 Cromwells, a Challenger, and 10 crew casualties. The Cromwells had been hit by AT guns, while the Challenger was ambushed by an infantry anti-tank team. This happened shortly before dark, and the Germans managed to capture the Challenger, somehow bringing it back behind their lines. This must have been the first Challenger to fall into enemy hands, and the Germans were eager to examine it. Down south in Eindhoven, A Squadron had a lot of ground to cover, and so split up in Pearson Force under the CO and Weatherby Force under the second in command. Together with the armored cars of the Royal Dragoons, they had spent a fairly quiet afternoon patrolling the city outskirts. Weatherby Force saw the most action when it investigated Best from the south, but the blown bridge prevented them from assisting B and C squadrons in their battle. This focus on the western flank distracted the Allies at a critical time, because that same afternoon the 107th Panzer Brigade closed in on the corridor from the east. The first reports of enemy armor filtered into General Taylor's headquarters late in the afternoon, but by that time it was already too late. Von Maltzahn, anxious to comply with his orders, had sent out his available forces to attack the Sonn Bridge just before dark. A small group of tanks and infantry turned left up the canal dike, crossed the Dommel culvert and closed in on the village. They overran an American outpost and then opened fire on a British supply convoy crossing the Bailey Bridge. Being caught unprepared, the defense of the vital bridge now fell on American headquarters and signal company men, glider pilots, airborne engineers, and anybody else who happened to be around. The defenders stood their ground and kept the German infantry at bay with small arms fire, but their bazookas failed to stop the Panthers, who responded by shelling the village, including the divisional command post. The lead Panther had almost made it to the bridge when an armor-piercing shot ripped through its fin side, followed by more hits until the tank caught fire and crewmen bailed out. A 57mm AT gun, landed by glider mere hours earlier, had been raised into position on a street corner just in time to catch a broadside angle on the lead Panther as it approached the bridge. With their first tank up in flames and darkness setting in, the Germans pulled back into the night. As the shooting died down, both sides tried to figure out what had happened and what to do next. Over on the German side, von Maltzahn was weighing his limited options. His instinct as a tank commander must have told him to maneuver, to bypass centers of resistance and concentrate on the weak points. Yet he was hemmed in between the Dommel and the Wilhelmina Canal. Coming in from the southeast was his only option. It was also clear that he couldn't actually move his tanks into Sonn itself. The only possible approach was over the canal bank, but this not only exposed his tanks, but also forced them to move perpendicular to the American AT guns, revealing their weak side armor. So von Maltzahn decided to switch his tactics around. Next day's attack would be carried out by the infantry, with the tanks acting as fire support. Rather than advancing his armor over the embankment, they would use it as cover instead. By positioning his tanks right at the junction of the Dommel and Wilhelmina Canal, they could shoot west onto the main road, while the embankment completely shielded them from the AT guns to the north. Static fire support isn't the ideal way to use tanks, as it neglects their mobility, but it was the best they could do given the circumstances. The most difficult mission was given to Hauptmann Vossage and his poorly trained light infantry battalion. They were to cross the Dommel at the Hooydonk watermill during the night and then push into Son at daybreak under the covering fire of the Panthers. As von Maltzahn was inspecting the footbridge at the watermill, General Taylor stood in the rubble of his headquarters exactly 1 mile to the northwest. His mission was fairly straightforward: defend the Son bridge and keep the road open for traffic. His problem was gathering enough forces before daybreak. Fortunately, the large glider serial of the previous afternoon had brought in men, artillery and AT guns. The 81st Airborne Anti-Tank Battalion, whose 57mm had already knocked out the 1st Panther, quickly set up the rest of their guns around Son. 20 pieces of 75mm pack howitzers from the airborne artillery had also arrived and were immediately put into position next to their gliders on the landing zone. Even more indirect fire was provided by the British 341 battery, who had deployed their 8 sextants northwest of Son. Infantrymen from the 1st Battalion of the 327th Glider Infantry Regiment were marched straight out of their gliders and into Son. They were disorganized and under strength, as many gliders had missed the landing zone, but what was left of Able Company set up west of the road, while the remains of Charlie Company took the eastern side. Lastly, 1st Battalion of the 506th, minus their Able Company, came marching up the road from Eindhoven and took up defensive positions behind the canal to the east of Son. With his own airborne forces in position, General Taylor had one more chess piece left on the board: the Hussars. When the German surprise attack struck Son, B and C squadrons were still fighting west of the landing fields near Best. General Taylor immediately called them back, but by the time they arrived the German attack had been repulsed, and so the Hussars regrouped in their lager northwest of Son. Tanks typically don't spend the night on the front line because visibility is limited and they are vulnerable to enemy infiltrators. Instead, they gather in a safe place just behind the front, called a lager or night harbor, to refuel, replenish ammo, maintain their machines, and if they were lucky, catch some sleep. Keeping tanks in reserve also made tactical sense, as their great mobility allowed them to rapidly deploy to an advantageous position once the enemy had shown his hand by attacking. Meanwhile, in the south, A squadrons to task forces didn't have the luxury of a quiet night harbor. They returned to Eindhoven in the evening, only to find the city in a state of panic. News of the German tank attack was exaggerated by wild rumors that the bridge at Son was destroyed and German armor was now headed for the city, so A squadron quickly occupied blocking positions along the roads leading into town. Opportunities for rest and maintenance were limited, as the crews took turns on guard duty throughout the night. They were not resupplied either, because the German Luftwaffe bombarded Eindhoven that night, and one unfortunate bomb destroyed much of the squadron's echelon just as it was forming up to resupply the tanks. The few hours of darkness on that late summer night were full of anxious activity as everyone prepared for the next day's battle. As one American rifleman was digging his foxhole just south of Son, he could hear the ominous rumbling of Panther tanks moving around in the dark. Just a few hundred meters away, over at the watermill, a farmer was kept awake by hundreds of hobnailed boots marching steadily over the narrow footbridge. Throughout the night, an orange glow lit up the southern horizon as Eindhoven burned. Meanwhile, in their lager just north of Son, the crew of a Challenger was going through their nightly routine of maintenance and resupply. They had heard about the German tanks and were loading up on AP ammo, making sure it was close at hand when the time came.
At 0500 hours, the CO was called into HQ American Division in Son and was there told of a threat to the canal bridge from the southeast by a German force including tanks. The regiment was immediately ordered to concentrate on the road at the north end of Son, and the CO, with the SO, Lieutenant Goldsmith, driving, went off in a scout car to recce the ground to the southeast and possible crossings over the River Dommel. CO turned east of the main road along the track at 445-245 in order to recce the track crossing the river at 456-246. It was only just light, and owing to this and the similarity in their uniforms, it was difficult to distinguish between American and German troops. And at a bend in the track at 453-241, that's right here, the CO and SO found themselves standing on the track with some 200 or more Germans walking past in front of them, some of them only about 5 yards away. They continued to walk past for some minutes, looking at the two British officers as they went, but appeared to take no notice. It was difficult to know what action to take, whether by adopting immediate aggressive action. In spite of the disparity in numbers, these Germans would have given up the fight and allowed themselves to be taken prisoner. However, it was decided that discretion was probably the better course, and the CO and SO therefore got back in their scout car. Just as they did so, the Germans opened up on them with a variety of weapons at short range, which hit the scout car in many places, but neither officer was touched. Lieutenant Goldsmith reversed the car back and turned round in the lane and drove away with some skill, and he and the CO thus got away from a somewhat remarkable and difficult situation. And those were the opening shots of the Battle of Son, which were fired right here at this track junction in the early morning mist on the 20th of September 1944.
As Colonel Taylor was racing back to Son, German assault troops were right behind him. Their leading squads were closing in on the bridge when they found their way blocked by Captain Miller's Charlie Company of the Glider Infantry. Their journey the previous day had been harrowing due to thick fog over the channel, and many gliders had cut loose prematurely or missed the landing zone, so instead of a company, Miller had to make do with just his first platoon and heavy weapons. This small force had to cover a wide front, stretching from the windmill by the road on their right down to the Dommel on their left. Thankfully, the fields to the south were open and easily denied by machine gun fire. Miller positioned at least one of his tripod-mounted guns near the windmill, where it had a field of grazing fire down to the Dommel. Small outposts were positioned forward of the main line, and the airborne engineers placed some anti-tank mines along the front. Miller's defense was put to the test shortly after Colonel Taylor's patrol ran into the enemy just south of their position. What followed was a short, sharp firefight as one of the company outposts fought for its life. The position was completely overrun, the men either killed or captured, but their resistance had given valuable early warning. Now on high alert, the Charlie Company gunners were ready and waiting when the first echelon of German assault troops appeared out of the mist. The American machine guns drove the Germans out of the open fields and into a few shallow ditches that led to the American lines. Captain Miller noticed this and ordered his riflemen into blocking positions, turning the infiltration routes into fatal funnels as the American glidermen fired down the length of them into the crawling German assault troops. Despite the disparity in numbers, the situation appeared stable thanks to Miller's good use of the train. The attacking German infantry simply lacked the firepower to suppress the dispersed American positions. This all changed when the sun came up and the early morning mist dissipated. A short distance to the east, with the rising sun at their back, Panther crews began spotting targets in the twilight. Their field of fire wasn't perfect. There were trees and bushes along the riverbank and houses along the byroad, but they could see enough to put some heavy enfilading fire along the length of Charlie Company. As the American fire slackened under the barrage, the German assault troops renewed their attack and Miller's line began to buckle under the pressure. The twilight also exposed British traffic on the road, which quickly turned into a shooting gallery for the German tanks. Among their victims was a fuel truck that exploded in a great fireball, blanketing the area in thick black smoke. The crucial lifeline that supplied 30 Corps advance to Arnhem was cut, and a great traffic jam extended all the way south into Belgium. Charlie Company was at the mercy of the Panthers as they stood safely outside bazooka range and presented their thick frontal armor to the airborne's 57mm AT guns. One American source claims their fire kept the German tanks at bay, but this seems unlikely as the Panthers were about as close as they could get without sinking into the marshy Dommel Creek. More likely is that the AT guns were powerless against the Panthers' frontal armor, while the exposed crews were slow to reposition and an easy prey for high explosive shells once discovered. What was needed was a mobile, protected AT gun capable of punching through the front of a Panther. It was around 0800 hours when Colonel Taylor made it safely back to the divisional HQ in Somme, where he was presented with the following situation. A strong force of German infantry was between the main road and the Dommel Creek and attacking Charlie Company from the south. The enemy's left flank had taken up positions in farms and orchards and was shooting traffic off the road. A force of around 5 Panther tanks was firing from the junction of the Dommel and Wilhelmina Canal, where the embankment completely shooted them from the north and faults in the train put them in a hold-down position from the west. The Hussars were the last force still left in reserve, and they would be the key to breaking the German attack. General Taylor ordered Colonel Taylor to immediately move one squadron south of the canal to stabilize the crumbling front line and keep the German infantry away from the bridge. Colonel Taylor gave this mission to his B squadron, just 8 tanks strong, while he ordered the equally depleted C squadron to move east into the Breugel area to see if they could find an angle across the canal into the flank of the Panthers. The desired end result was an L-shaped position with B squadron on the southern tip and C squadron 90 degrees to the east, allowing them to converge their fire on the German tanks in the middle, catching them in a crossfire that exposed their weak side armor to one of the 2 directions. Geography played a key role in the upcoming tank duel, and many of the important terrain features are still present in the current landscape. Overlaying a modern satellite image reveals that the basic layout remains the same. There is the main road on the left, the smaller by-road to its east, then the Dommel Creek, and again a road connecting Breugel with Nederwetter. Crossing these north-south features is the Wilhelmina Canal going east to west. Tracing the L-shaped position again, B Squadron's tip is along the main road south of Sonn, where the windmill used to be. It was demolished after the war, but this modern-day electricity tower roughly marks the spot. C Squadron's tip is at the minor bridge over the canal to the east. This bridge was destroyed during the war, but has since been rebuilt. The German tanks stood in the low-lying fields at the junction of the Dommel and Wilhelmina Canal. While they would have spread out in individual firing positions, their approximate location can be identified from afar by this patch of poplar trees. The best boots-on-the-ground overview is gained from the raised canal embankment near the inner corner of the L-shape. Out on the left, a row of poplar trees marks the canal embankment. Panning to the right, the exposed, marshy ground along the Dommel can be seen, although the creek itself is very hard to see, even from an elevated viewpoint. The patch of tall poplar trees marks the shore of the eastern bank where the German tanks fired from. Further to the right, some of the farm buildings along the by-road come into view. This is roughly where Charlie Company was dug in when it came under fire from the Panthers on their left. In the distance, the electricity tower marks the position of the old windmill where B Squadron was going. Following in their tracks down the vertical side of the L-shape leads to the site of the former windmill. Getting a clear angle from here to the Dommel is made difficult by the many barns, houses, trees and hedgerows that line the by-road to the east. There is one narrow sideline that still offers a shot to the Dommel, approximately from where the windmill stood. Putting a camera 3 meters off the ground to simulate the vantage point of a tank commander results in this view. Note again the patch of poplar trees about 800 meters away as the rough location of the German tanks. Also note the slight downward curve in the terrain as the fields dip down to the creek. Moving the camera across the field opens up a clearer angle through a gap in the foliage. The culvert marking the junction of the Dommel and Wilhelmina Canal can be seen in the distance. Moving over there to get the German perspective is done by going east along the canal embankment, traveling along the horizontal line of the L shape. Note the elevation difference between the top of the embankment and the fields to the right of it, easily enough to completely hide a Panther from the north. Crossing the Dommel culvert and then immediately going right leads to their approximate firing position. According to the British War Diary, the German tanks stood very close to the marshy creek, which was made possible by the Panther's surprisingly low ground pressure despite its overall weight. A German source does mention trouble with the swampy ground, however, noting that some tanks had gotten stuck the previous evening and were recovered during the night. Placing the camera 3 meters off the ground for the tank commander's perspective gives the following view. The buildings and trees along the byroad block the line of sight to the main road, although the electricity tower marking the old windmill can still be seen. Moving south along the Dommel, an alternative firing position gives the following view to the west. Again, the main road is obscured by thick foliage, with the electricity tower being the only visible reference point. Finally, there is C Squadron's tip just north across the canal from here. While this position should have given them easy flanking shots into the Panther's vulnerable sides, the steep embankment created a blind spot at the junction of the two waterways that C Squadron could not fire into. As for the 1944 battlefield, solid photographic evidence is unfortunately rare. This aerial photograph gives a good overview, but is too distant to pick up individual structures or trees. This photo from 1919 shows the construction of the culvert and gives a glimpse into the fields directly south of the canal. The curving Dommel is clearly visible, and a few farms can be seen in the distance to the southwest, about where the byroad is. Moving back to the windmill, these wartime pictures, facing roughly southeast, show its position next to the main road. This picture faces more to the east and reveals some dense tree lines in the distance that would have complicated the fields of fire. Also note the battle damage, especially the rubble at the base of the mill. Finally, this picture faces to the north as the Son church tower can be seen in the distance. Also visible are poplar trees lining the Wilhelmina Canal and a tree line east of the mill along the byroad. So, while the 1944 battlefield was not as densely packed as it is now, these pictures show that there were still plenty of tree lines, hedges and the occasional farm building to break up sightlines, as B Squadron is about to find out. It was sometime past 8 in the morning when Major Ralph Donnell led his B Squadron into battle. His 8 remaining tanks, mostly Cromwells with at least 1 Challenger and 1 close support variant, rolled over the Bailey Bridge and followed the main road south. Their left flank was shielded from the Panther's fire by a dense row of houses and gardens that extended a few hundred meters south to the windmill, giving the British tanks some room to maneuver without getting sniped from across the Dommel. Arriving near Charlie Company's hard-pressed position, the regimental history calmly notes that the squadron could see many infantry crawling about a few hundred yards away, and these were quickly dealt with. The arrival of B Squadron doomed the German infantry west of the Dommel. They had been unable to quickly break through Charlie Company's defenses and now found themselves stuck in the open fields as the sun came up and overwhelming firepower was brought down on them. American airborne howitzers and British self-propelled 25-pounders had already zeroed in and were laying down a protective barrage in front of Charlie Company. Firing from the landing fields, their high-explosive shells whistled over the roofs of Somme before crashing down on the exposed German troops. Sealing their fate were the 8 tanks of B Squadron that rolled into view. The Cromwell may not have been a fantastic tank killer, but against infantry it was devastating. They fired belt after belt from their Besa machine guns and sent powerful high-explosive shells into any and all ditches, bushes and tree stands that offered shelter. The war diary doesn't go into such detail. It merely speaks of clearing up the situation after a good deal of fighting. Meanwhile, a German source stresses strong artillery and tank fire being concentrated on their exposed position. The people that were actually caught in this storm of steel described it differently. Franciscus Schuithuizen lived on a farm next to the watermill at Hooijdonk. His neighbors had fled when the German tanks appeared the day before, but he stayed behind with his pregnant wife and 3 young children. They sheltered in their basement as the battle raged around them. Their farm burned down and shrapnel killed their livestock. By mid-morning, Franciscus wrote that the firing continued to grow in intensity until it became an indescribable hurricane of tank fire interspersed with the rattling of machine guns and rifle shots. Bullets shrieked through the air and bounced off the walls. Shells howled. It was as if all hell had broken loose as an hour went by. The surviving German infantry, seeing their hopeless situation, broke and ran. Major Ralph Donnell was eager to chase them far away from the main road and moved his tank up to the windmill for a better shot, followed by his second-in-command in a close support Cromwell. The British and American sources differ on what happened next. The following version, based on the regimental history and an eyewitness account, seems most plausible. As Ralph Donnell and his second-in-command moved beyond the windmill, they approached the minefield that American engineers had placed the previous evening. Most American sources claim that both tanks drove over these mines and blew up, but this is absent from British records. Instead, it seems the tanks were brought to a halt by Captain Miller, who ran up to warn them, a considerable feat as he was wounded in the leg by this point. As the 2 Cromwells slowly reversed away from the minefield, they came under fire from a Panther. Up until now, it appears the German tanks were powerless to stop B Squadron's rampage, probably because Major Ralph Donnell was briefed on their position and made sure to keep his tanks outside their field of fire. The German tankers must have seen and heard the telltale signs of enemy tanks, their dust trails, the slow chattering of Besa machine guns, and the thump of cannon fire, followed by drifting clouds of debris. But the Dommel Creek prevented them from maneuvering into a firing position. However, when Major Ralph Donnell and his second-in-command moved up a little too far, one Panther crew saw the boxy shapes of their Cromwells appear from behind the windmill, then suddenly halt and slowly reverse. The commander talked his gunner on target over the Panther's intercom, giving him the range and direction. The gunner zeroed in his sight for AP ammo as he peered through the narrow magnified optic in search of his target. The loader, meanwhile, scrambled to get an armor-piercing round into the gun. All the while, the driver and radio operator sat helplessly in the hole, blind to what was happening in the turret, but hearing every word. Seeing his target, the gunner moved his triangular aiming point onto the Cromwell, shouted a word of warning, then fired. Over on the receiving end, a distant muzzle flash gave a split-second warning, followed near instantly by the impact. Private Mullins from Charlie Company witnessed the action from a foxhole next to the mill. He misidentifies the tanks, but his account is nonetheless insightful. To quote, "Then all hell broke loose. Bullets began to pop in. A Sherman tank rolled up. It stopped 30 to 50 feet from me, then another one pulled up. I saw Captain Miller climb on one of the tanks to warn them about the minefields. Then I saw the first tank that rolled in take 2 rounds high on its turret from a Tiger. Meanwhile I heard, 'Mullins, get your machine gun.' I headed for the gun at the same time the anti-tank gunner fired his first round at the tank. The shell passed a couple of feet over our heads and the muzzle blast was 10 feet or more. At this instant, the second tank took a round from the Tiger. The tanker put it in reverse, spun her around and headed straight for my hole and stopped right over me. Mullins was nearly crushed and buried alive as the sandy forecastle collapsed under the weight of the Cromwell, but thankfully Captain Miller saw it happen and hurried over to get the tank moving. Mullins didn't blame the British tankers, saying that, "I'm sure the tank guys didn't have it all together after taking the round from the Tiger." This eyewitness account fits in nicely with the regimental history of the Hussars, which describes the action as follows. FHQ had placed itself beside a windmill, perhaps foolishly, for almost immediately the squadron leader's tank was hit, and a few seconds later the second-in-command's gun had a large chunk removed from the barrel, fortunately with no casualties. Luckily, a 17-pounder SP gun, directed by Major Bolmain, quickly accounted for the offender with a direct hit on what was thought to be a Panther. And there it is, a Challenger destroyed a Panther, and from the front no less. Unfortunately, this is both the most interesting and least documented engagement of the battle. The war diary doesn't mention it at all, the regimental history only gives its brief description, and none of the photographed wrecks can be conclusively connected to this specific Panther. It would be fascinating to know whether APDS or regular AP was used, where the round hit and what kind of damage it did, but such details didn't make it into the sources. It's not even clear where the Challenger stood exactly, only that it must have had an angle on the Panther, which in turn had an angle on the windmill. Most information is concentrated in the following line from the regimental history. Luckily, a 17-pounder SP gun, directed by Major Bolmain, quickly accounted for the offender with a direct hit on what was thought to be a Panther. The first thing to note is the use of 17-pounder SP gun to refer to the Challenger, which is only done in this particular instance, but it's unlikely the author could have meant anything other than a Challenger given the circumstances. More significant is the word quickly, as this implies the Challenger was already in a position to respond, but exactly how much time this took is unclear. The regimental history claims the two Cromwells were hit seconds apart, while Private Mullins remembers a total of 3 hits. Even accounting for observation and adjustment between shots, the Panther should have fired these in less than a minute, so it was within this brief period that the Challenger reacted. Making this possible was the quick intervention of Major Bolmain, who is explicitly mentioned for directing the Challenger on target. Bolmain was the regiment's second-in-command, and he probably accompanied B Squadron because it was so under strength. As the second-in-command, Bolmain had his own 75mm Cromwell that he may have used, but he could also have taken a scout car or a jeep, or perhaps dismounted to observe on foot. He may even have used the windmill as an observation post. One way or the other, the regimental history credits him with the important role of directing the Challenger on target, meaning he was both in a position to spot the Panther and relay this information back to the Challenger. Note, however, the statement, what was thought to be a Panther, implying the target wasn't positively identified. Bolmain probably saw muzzle flashes and clouds of dust and maybe the vague outline of a tank. That he did observe a direct hit was likely due to the Panther subsequently catching fire. That the Panthers were difficult to spot is not surprising given the circumstances. Pictures taken the previous day show they were covered in camouflage netting and foliage. They were over 800 meters away, stationary, and had time to carefully select their positions, making sure to stand in the shade to avoid detection from the air. The British War Diary even claims they were hauled down from the west, which seems unlikely given the flat fields, but illustrates just how well hidden they were. The buildings and trees along the byroad further complicated spotting by fragmenting sightlines, forcing the British tanks to move to open up new angles past these obstructions. It was likely the search for a better view that caused Major Ralph Donnell and his second-in-command to overextend beyond the windmill and into the Panther's field of fire. These same fragmented sightlines must also have made it difficult for the Challenger to find a suitable overwatch position, as it simply could not see everything all at once from a single spot, especially not when it also had to keep its own safety in mind as it was a priority target for the enemy. That would explain why, even with the help of Major Bolmain, the Challenger could only respond after the enemy had fired 3 shots, enough to wipe out a troop had their aim been better. However, while things could have gone smoother and a fair bit of luck was involved, the engagement does illustrate the Challenger's role perfectly. It brought a mobile, protected 17-pounder to the right place at the right time and used it to protect the Cromwells against a heavily armored threat they would otherwise have been powerless against. With a single, well-aimed shot, the Challenger had finally put theory into practice. Taking a step back to the overall battle, it's now past 10 in the morning and the German attack has been decisively repulsed. The loss of 1 Panther seems to have disheartened the rest as they are seen pulling back under the cover of a smokescreen. The remaining 6 tanks of B Squadron pushed down the road to clear it for traffic. They split up in 2 troop-sized elements and advance in bounds to provide mutual support. Because they don't have infantry with them, they sweep suspected enemy positions with fire instead. This is for good reason, as there are still some German holdouts in the farms and orchards along the road. One of them wounds Sergeant Yeomans in the head with small arms fire, adding another casualty to the long list of tank commanders who were killed or wounded in their exposed position. About halfway down the road to Eindhoven, B Squadron makes contact with Sherman tanks of the 44th Royal Tank Regiment. The road was now clear, but there were still Germans sheltering in the wooded marshes along the Dommel Creek. The Hussars didn't dare to venture into such close country unescorted, so they waited until 11:45 for the American glidermen to reorganize themselves for a counterattack. A and C companies, backed up by the tanks, formed a sweep line from the road to the water and cleared the area as far south as Bocht, firing on suspected enemy positions as they advanced. They must have passed ditches full of enemy casualties, because over 50 Germans were killed and many more wounded. Even more appeared out of the bushes with their hands in the air, adding up to a total of 185 prisoners, including the battalion commander. The road to Arnhem had been opened again, but the battle wasn't over yet. Turning back the clock to the moment the German tanks retreated, which must have happened sometime between 10 and 11, it's C Squadron's turn to get into action. While B Squadron received the difficult mission of facing the Panthers head-on, Colonel Taylor ordered his C Squadron under Major Courage to find a flanking position to the east. The War Diary makes no mention of their actions until, later in the day, C Squadron operated to the east, north of the canal in the area Breugel 4526, and 1 Panther tank was knocked out by the 17-pounder tank of 4th Troop firing across the canal from north to south after some valuable recce of this tank had been carried out by patrols of Recce Troop under Lieutenant Butler and Sergeant Spanton. Unfortunately, the regimental history, despite being written by Major Courage of C Squadron, adds some confusing details to this report. To quote, "The enemy force in this battle included at least 5 Panther tanks, which were located near the junction of the river Dommel and the canal under the shelter of the high canal banks, behind which they were hauled down to B Squadron to the west and turret down from the north, where C Squadron had sent a troop to try to get a shot at them. These Panthers were in a practically impregnable position, but later on, one of them was knocked out by an American bazooka man. It was then found to have a 17-pounder shell hole through its turret, fired by 3rd Troop C Squadron from the north. It had only been possible to get a shot at this tank at all owing to the most skillful reconnaissance and spotting by Lieutenant Butler and Sergeant Spanton. So, according to Courage, it was his 3rd Troop instead of the 4th, and it wasn't a clean kill by a Challenger, but an American bazooka that fired the fatal shot. Fortunately, there is some clear photographic evidence of this specific Panther that can provide answers. This picture gives the best overview and allows the wreck to be located. The trees directly in front of the tank line the minor road that leads from Nederwetter across the canal to Breugel. In the distance, the 2-story house directly northeast of the bridge can be seen. The Wilhelmina Canal can be identified by the row of poplar trees running east to west. The debris in the left foreground is what's left of the home of Piet Zeikens, who lived in this area. Many of these features are still present in the current landscape. The road is still lined with trees, and so is the Wilhelmina Canal. In the distance, glimpses of the rebuilt bridge and the two-story house can be seen. Given the position of the wreck, it was clearly moving east, away from its firing position at the Dommel and heading for the road back to Nederwetten. This confirms it was retreating, as was observed by B Squadron, and was destroyed in the open field directly south of the canal where C Squadron claimed its kill. With the location determined, the next question is what exactly knocked it out. A penetrating hit is clearly visible on the upper right hull. This close-up provides an even better view of the damage. The distinctive crack in the armor confirms it's the same tank and indicates the use of poor quality steel typical of late war Panthers. The first thing to note is that this isn't the bazooka hit that Major Courage mentions because it's too big and lacks the distinctive splash marks of a shaped charge detonation. Instead, the damage is much more consistent with a full-caliber 17-pounder AP shot, even though Courage claims this hit was in the turret and not the hull. The biggest problem is that the damage is visible on the southern side, while the shot should have come in from the north. Upon closer inspection, however, the hole appears to be caused by the exit of a round. The edges are very irregular in shape and seem to be pushed to the outside. It's not impossible for armor-piercing rounds to go straight through a tank, especially if the gun is powerful and the armor thin. Going clean through the sides of a Panther is within the 17-pounder's capabilities, especially at short range. The reason most armor-piercing rounds didn't overpenetrate and leave an exit hole is because they often broke apart or lost so much energy that they ricocheted through the interior. Additionally, many AP rounds of the time contained an explosive charge that detonated inside the target, further deforming the projectile and reducing its chance of punching through the other side. The 17-pounder's AP round didn't have explosive filler. It was a solid projectile weighing nearly 8 kilograms that left the barrel going almost 900 meters a second. In theory, this gave it enough energy to penetrate nearly 200 millimeters of armor under ideal circumstances. The Panther's side armor was just 50 millimeters thick, only slightly angled, and struck at fairly close range. None of this is conclusive evidence, but it illustrates the possibility of a 17-pounder AP shot going straight through the side of a Panther and causing damage as seen on the photo. This would confirm that the fatal shot came from the north where C Squadron was, making this Panther the victim of a Challenger. Lastly, this explanation fits the War Diary's more reliable version of events. How Major Courage came to his conclusion remains unknown. As for the internal damage, this photograph gives the best side-on view of the impact. Given the size of the hole, it likely wasn't a sub-caliber APDS, but a full-sized AP shot. The bare metal in the center of the tank is a telltale sign of an internal ammunition fire, as the intense heat melts away the Zimmerit anti-magnetic coating on the outside. The hit is roughly in line with the commander's cupola and third road wheel from the rear, meaning the shot would have entered the back of the fighting compartment where the turret crew and some of the ammunition are located. When fully stocked, 4 stowage racks containing a total of 33 main gun rounds sit directly in the path of the penetration. While these racks may have been depleted after a morning of shooting, the clear fire damage indicates that at least some cartridges ignited. It's possible the driver and radio operator in the front of the hull may have had time to bail out before the fire spread, but the 3 men in the turret were less fortunate. It's highly likely the commander and loader were struck by the 17-pounder's projectile or the accompanying steel splinters. The gunner was seated further forward in the turret and may have survived the initial impact, but this only put him in a worse position, as he had no escape hatch of his own and so was trapped with a raging fire and the bodies of the commander and loader between him and the only exits. The German War Diary acknowledges the loss of 2 tanks outside Sonn, but makes no mention of crew casualties. It does claim they were knocked out by AT guns, indicating that there were survivors who had witnessed incoming high-velocity armor-piercing rounds, but that they misidentified the source as towed AT guns instead of Challengers. Speaking of Challengers, the next question is where exactly C Squadron fired from. The only explicit mention of their location in the sources is that they were east of Sonn and north of the canal, somewhere in the vicinity of Breugel. One road leads directly south from this village to the canal, and because the fields on either side are soft and lined with ditches, it stands to reason that the tanks followed this road. In order to shoot over the canal, the Challenger would have had to be fairly close to the northern bank to peek over the edge. So combined, these 2 clues indicate a probable firing position on the road directly north of the bridge. This wartime photograph shows the location from the southern bank. The trees in the distance mark the road from Breugel that C Squadron likely took. Again, the landscape has remained largely the same. Following the road would have given the Challenger a more gradual approach to the embankment, as the roadway is on a gentle upward slope, whereas the fields to the side of it remain level and the embankment is subsequently steeper there. The further you move away from the road, the steeper the embankment becomes to the point that a tank can no longer fire over it. By following the road, the Challenger would have started in a turret-down position, but as it crept closer to the bridge, the elevation gently increased and the tank transitioned into a hull-down position, allowing the gun to fire over the bank while the hull remained safely behind it. Spotting anything from such a position would have been difficult, which would explain why the sources emphasized the valuable reconnaissance carried out by Lieutenant Butler and Sergeant Spenton. As the Challenger stayed back in a safe, turret-down position, they must have investigated the canal bank in their scout car and probably dismounted for a better look, perhaps using the house that still stands there today to peek over the opposite bank and reveal the German tanks below. They may have observed them for some time as the Panthers remained in their impregnable position, until one of them was knocked out by B Squadron's Challenger, prompting the others to retreat. The Panthers deployed a smokescreen to cover their rear as they turned around, but this would only have obscured their west, not the north where C Squadron was lurking. As one by one the Panthers left protection of the embankment, the scouts whistled the Challenger forward to seize the opportunity. This would have taken some time, allowing the first 3 to escape, but by the time the unfortunate number 4 dashed across the field, the Challenger was in a hold-down position, knew where to look, took aim and fired. At a mere 400 meters, the shot connected near instantly as the Panther ground to a halt and started to burn. The second enemy tank of the day was knocked out, by a different squadron and from a different position, but once again by a Challenger, with a single shot and with the help of a spotter. Back to the bigger picture. The German attack on Sonn has been decisively repulsed by noon, and the main road was once again open to traffic. Having played their part, B and C squadrons remained in their defensive positions for the rest of the day. They had suffered no fatalities and none of their tanks were permanently knocked out. In return, 2 Panthers were up in flames, while the 3 remaining tanks pulled back to Nederwetter along with the shell-shocked survivors of the infantry battalion. This small village wouldn't remain safe for long, as to their south, A Squadron was on the move, looking for an opportunity to strike back at the Germans. A Squadron had been left in Eindhoven the previous day, and in order to cover more ground, had split up into a Pearson force under the squadron commander and a Weatherby Force under the second-in-command. Both had spent an anxious night guarding the roads into town, while behind them German bombers set fire to the city center. When it became clear the next morning that the Germans were not attacking Eindhoven but Sonn, A Squadron went on the offensive. Pearson Force moved east, chasing what turned out to be a false alarm, but Weatherby Force had much better luck as it set out for the village of Nederwette. As B and C squadrons were the shield defending Son, Weatherby would be the sword striking back in retaliation.
Lieutenant Egerton reported seeing a Panther moving northeast in area 458237, which he fired at and destroyed with his first shot. Sergeant Nesbitt fired at a second Panther in the same area, but this withdrew. About 40 minutes later, Lieutenant Egerton reported a third Panther in the same area, which he destroyed after firing 4 shots. And those shots would have been flying over this exact field, coming from that direction, flying over our heads and striking the Panthers over there. And they were not fired by a high-velocity 17-pounder of a Challenger, but by the relatively weaker guns of the regular Cromwell tanks. This didn't matter, however, because they were striking the Panthers broadside in their weaker side armor. What made this possible was a daring flanking maneuver carried out by Captain Weatherby, who led a small force on a bold counterattack that put them into a position that allowed for those devastating side shots on the unaware German Panthers just outside the village of Nederwette here. And the war diary records this action in exceptional detail. So we will use this to recreate the Battle of Weatherby Force step by step.
When the 24-year-old Captain Weatherby set out on his counterattack, he did so with little more than a reinforced troop. As the squadron's second in command, Weatherby had a close support Cromwell as his personal mount. Its howitzer made it a useful addition for heavy smoke laying and high-angle explosive fire, but unless this was absolutely needed, the vehicle served as more of a mobile protected command post. The core of Weatherby Force was Lieutenant Egerton's 3rd Troop, already familiar from the Liesel engagement discussed in Part 1. The troop was still at full strength, with 3 regular Cromwells and 1 Challenger. Assisting Egerton was Troop Sergeant Nesbitt, Corporal Nichols commanded the 3rd Cromwell, and the Challenger was led by Sergeant Gadd. 2 scout cars from the regiment's own recce squadron accompanied Weatherby. One was led by Lieutenant Sparrow and the other by Corporal Hunter. These were either Humber or Daimler scout cars, both models being fast but lightly armored and only armed with a single Bren gun. A contingent of American paratroopers from Able Company of the 506th Regiment also accompanied Weatherby. This unit had suffered heavy losses on day 1 of Market Garden and was short on officers, so they were assigned to the Hussars as close infantry escort. Its 1st platoon was so under strength that it was left behind in Son on guard duty, while it was likely the 2nd platoon that rode on the back of Weatherby's tanks and 3rd platoon that joined Pearson's force. Later in the day, Weatherby was reinforced by A Squadron's 2nd Troop under Lieutenant Carew. Less is known about this troop, but they seem to have been at full strength. 2nd Troop also brought a patrol from the Royals with them. A patrol in this context typically refers to the smallest form of organization below the troop level. In most cases, it was a mix of 1 light scout car and 1 heavier armored car, but this isn't made clear in the sources. These reinforcements would arrive later during the battle. When Captain Weatherby first drove off towards the sound of the guns, it was just him, Egerton's troop, 2 scout cars and some American paratroopers. At daybreak on the 20th, Weatherby Force was still manning its roadblock north of Eindhoven when it received a new mission. Unlike B and C squadrons, who got their orders directly from the American division commander in Son, A Squadron was under command of Colonel Sink of the American 506th Parachute Regiment, who was tasked with defending Eindhoven. To relieve pressure on Son, Sink ordered his armored units to conduct counterattacks as soon as possible. Pearson's force went east as far as Geldrop, but made no contact with the enemy. Easy Company, with a squadron of Shermans from the 44th Royal Tank Regiment, crossed the Dommel at Opwetten and headed for Nuenen, but ran into strong German resistance outside the village and was forced to retreat. A follow-up attack by another company with a squadron of Shermans also came to a standstill. Just to their west, Weatherby Force was ordered to cross the Dommel at Soeterbeek and advance up the road to Nederwetten, heading straight for the enemy tanks that were shelling Son. As they set out in the early morning mist, the British tankers and American paratroopers must have heard the distant rumble of gunfire intensify as the battle for Son unfolded to the north of them. Listening in on the regimental radio net, they would have heard chatter as B and C squadrons entered the fray, culminating in reports of enemy tanks being brewed up by the Challengers. Before he could join the battle, Weatherby first had to get his tanks across the Dommel, and this was no easy task. Reaching the bridge at the Soeterbeek estate, the sight that greeted him was a narrow, rickety structure and a signpost imposing a weight limit of 8 tons. Weatherby was willing to take the risk. First sending the scout cars across, they checked out the opposite bank and found no signs of the enemy. What Weatherby didn't know was that the previous day, German scouts had approached the bridge from the other side and were so unimpressed they didn't even dare drive one of their half-tracks across, much less a 45-ton Panther tank. It should be noted, however, that these were not the brigade's specialist scouts, as they were still on the train, but instead an improvised reconnaissance party from one of the infantry units, who were presumably less skilled in judging structural integrity. It seems they underestimated the bridge because the first of Weatherby's 28-ton Cromwells made it across without collapsing, even if damage to the guardrails shows it was a very tight fit. It was fortunate then that the Challenger was no wider than the Cromwell, and despite weighing 4 tons more, it too made it over without incident. Weatherby Force had crossed the Dommel and was now on the loose in enemy territory. The Germans had apparently misjudged the capacity of the Soeterbeek bridge and would soon face the consequences of leaving it intact and undefended. Weatherby's tanks regrouped at the junction just beyond the bridge as Lieutenant Sparrow and Corporal Hunter checked out the road ahead in their scout cars. These were small, fast and remarkably quiet, allowing them to approach enemy positions undetected. Sparrow and Hunter advanced in deliberate bounds, one car moving up as the other stood on overwatch in a concealed position. This leapfrogging continued until they reached a bend in the road that made a good intermediate position for the tanks. Sparrow called it in over the radio, and soon the Cromwells rolled into view and shuffled into concealed positions between the farm buildings. With the tanks providing overwatch, the scout cars continued up the road as before. Sidelines became shorter as they approached the village, the open fields making way for farms and orchards on both sides of the road. Lieutenant Sparrow closed in on the southern outskirts when he spotted movement ahead. A small group of German infantry, one of them riding a bike, were seemingly unaware of the approaching British scout car. Sparrow opened fire with the Bren gun, killing one and wounding another before pulling back. The American paratroopers were sent forward covered by the tanks, and after a short firefight, came back with 3 German prisoners. With the area secure, the tanks moved up and went into position among the buildings and orchards lining the road just south of the village. Their fields of fire are captured perfectly on this aerial photograph taken just a few days earlier on the 11th of September. While the British sources somewhat confusingly claim they had entered Nederwetten, their map references indicate that Weatherby Force had actually taken up position in the stretch of buildings along the road just south of the village. Lieutenant Egerton had been leading the tank column and occupied the northernmost position, facing northwest with a field of fire stretching to about 640 meters. Troop Sergeant Nesbitt stood just behind him, facing slightly more to the west with a similar sideline. Corporal Nichols in his Cromwell and Sergeant Gadd in the Challenger were watching the east and southeast with a field of fire of about 550 meters. Captain Weatherby's exact location is unknown, although presumably he was in a central position for easier command and control. The American infantrymen had most likely dismounted and taken up positions in the surrounding buildings and orchards. Completing the all-round defense were the 2 scout cars that had repositioned to the rear and were now watching the road to the south. It's worth noting the use of the Challenger as a flank guard instead of looking north where the enemy tanks were likely to be, as this again highlights the importance of holding it back in a reserve position until absolutely needed. As for the bigger picture, the Hooijdonk watermill and its small footbridge can be seen to the north. When Weatherby Force entered the area around noon, the shell-torn fields west of the Dommel were still being cleared of German infantry as small groups of stragglers made their way back across the creek. Out of frame to the north is the junction of the Dommel and Wilhelmina Canal, where the 2 Panthers were destroyed by B and C Squadron's Challengers. The 3 surviving Panthers took the road back to Nederwetten around noon and regrouped near this cluster of buildings next to the ruins of the old church tower. A short distance to the east lies the village of Nederwetten with its new church tower. The village is characterized by the fork in the road, with the north leading to the Wilhelmina Canal where C Squadron was positioned, the east going to Nuenen where Easy Company was attacking, and the southern road leading to Eindhoven where Weatherby Force had set out from. The village pub sits directly in the fork in the road and was used by von Maltzahn as his 4th Brigade headquarters, but was likely evacuated by the time Weatherby arrived. Speaking of Weatherby Force, they had occupied their position among the roadside farms sometime before 1300 hours. Enemy small arms fire was directed at an unknown target from the woods to their east, and some American paratroopers went over to investigate. As this was going on, Lieutenant Egerton detected movement to the northwest. A cloud of dust, black exhaust smoke, or perhaps a glint of metal drew his gaze to the feud between the old tower and a bend in the Dommel, where he spotted a Panther tank moving northeast towards Nederwetten. Egerton calmly guided his gunner, Trooper Crump, on target, giving him the direction to traverse and the approximate range. At over 600 meters, landing a hit with the medium-velocity gun of the Cromwell required some guesswork, especially against a moving target. Crump quickly adjusted for range and lead, then fired. It took about a second for the shot to reach its target, curving slightly downward as it flew across the fields, before striking the Panther broadside and instantly setting it on fire. At the same time, Sergeant Nesbitt spotted another Panther further to the right, heading for the cover of the village. His gunner managed to fire a single hasty shot that disappeared among the houses along with the enemy tank. No hit was observed, no smoke seen, and therefore no kill claimed, but photographic evidence confirms this tank came to a standstill in the village with a severed right track. German sources indicate they may have blown up this tank at a later time to avoid capture, which would explain the fire damage in the picture. But right after Nesbitt's hit, it was at least immobilized and probably abandoned. Following the brief 2-shot engagement, things became quiet for about 40 minutes. The sources mention no change of positions during this period, nor was the Challenger brought forward despite the clear presence of German armor to their northwest. Shortly before 1400 hours, Egerton again saw movement south of the old tower. A 3rd Panther dashed across the field, making the same mistake as the first one. Gunner Crump already knew the correct range and lead and scored another broadside hit with his first round. The Panther refused to catch fire, so another 3 rounds were shot through the thin side armor until it burst into flames. The war diary records 2 hits in the driver's compartment that likely brought the tank to a standstill but didn't hit any ammo. Another shot that entered the engine and may have ignited fuel, and a 4th round that hit just above the tracks, probably meaning the fighting compartment where most of the ammunition was stored. It's not entirely clear what the Panthers were doing west of the village or why there was a 40-minute gap between their actions. What is clear is that the Germans were disorganized and primarily concerned with falling back to safer positions. The German war diary describes Weatherby's attack as overtaking them during their retreat to Nederwetten implying they were surprised by the presence of British tanks so close to the village. Given the total number of free Panthers encountered in Nederwetter, it stands to reason that these were the free survivors from the 5 tanks that had attacked Son earlier in the day. They must have been exhausted by now and distressed over the loss of 2 of their tanks, perhaps including the unit commander, which would explain their evasive behavior. As the Germans lost 1 tank after another, Weatherby Force was only getting stronger. Major Pearson, finding no enemy east of Eindhoven, but hearing of Weatherby's battle over the radio, had sent his 2nd Troop under Lieutenant Carew and a patrol of the Royals to reinforce Weatherby around 1400 hours. They arrived sometime later in the afternoon and took a position east of the road to better cover the exits from Nederwetter. The most forward position was taken by Sergeant Gibson after being guided to it by Lieutenant Egerton, who had dismounted to do so despite increasing enemy small arms fire. Unfortunately, it's not clear in the sources whether Gibson was the troop sergeant in a Cromwell or a sergeant commanding a Challenger, but given the context he was likely a troop sergeant in a Cromwell. Meanwhile, the patrol of the Royals reinforced the 2 scout cars guarding the rear. Gibson had only just moved into position when he saw 2 vehicles on the road leading east out of Nederwetter. He identified them as troop-carrying vehicles, most likely half-tracks, and engaged them, destroying one and damaging the other. Infantry was also fired at, presumably the occupants of the half-tracks. A 3rd half-track was spotted moving near the church, where it made the fatal mistake of going right at the fork in the road, bringing it face-to-face with one of the British tanks as it rounded the corner. A photo of the wreck pinpoints its exact location to a row of houses that still stands there today. Note the possible entry hole in its right front, which is consistent with the direction the British tanks were firing from. The surviving occupants scrambled out of the damaged half-track under fire, as is evident from the damage to the building behind them, and 2 of them surrendered. By now, the Germans were aware of Weatherby's location and concentrating small arms fire on the area. A high-velocity gun fired down the road, called an 88 in the sources, but presumably another Panther, and at 1540 hours, Weatherby decided to fall back to the intermediate position further down the road. One by one, the tanks turned around and disengaged. Lieutenant Egerton was the last to leave, providing cover until everyone was safely pulled back. The Germans did not pursue, and Weatherby Force remained in position until ordered to return to Eindhoven at 1700 hours. The small force had completed its mission and inflicted significant losses on the enemy without suffering any damage or casualties. The battle on the 20th of September had cost the 107th Armoured Brigade 5 of its prized Panther tanks and numerous half-tracks, while the supporting infantry battalion had been decimated. They had failed their mission and were on the retreat the next day, but renewed their attack on the narrow Allied corridor on the 22nd and 23rd. The Hussars, meanwhile, had fulfilled their role in Operation Market Garden and rejoined the 11th Armoured Division on the 21st of September. Lieutenant Colonel Taylor received the Distinguished Service Order for his command of the regiment during the operation. Captain Weatherby was awarded the Military Cross for his action at Nederwetter, in particular his personal courage under fire and his calmness and skill in handling his small force. Lieutenant Egerton was praised in the War Diary for his coolness and effective troop leadership and would earn a Military Cross for his actions at Liesel 4 days later. The engagement at Nederwetter stands out because Weatherby Force inflicted the heaviest tank losses on the enemy in the least amount of time, yet did so without actually using its dedicated tank destroyers. Despite being briefed on the presence of Panther tanks and then encountering them outside Nederwetter, it appears neither Weatherby nor Egerton considered it necessary to move the 3rd Troop Challenger into a suitable firing position, while the actions of the 2nd Troop Challenger that arrived later in the day are similarly absent from the records. Assuming these were deliberate tactical choices and no crucial details have been left out of the sources, it shows that Challengers were not brought forward if enemy tanks could be effectively engaged from the side by Cromwells. In fact, it's Weatherby's skillful positioning to achieve flanking shots that's considered most impressive by his superiors. To quote his military cross recommendation, "He disposed his force with such skill that his tanks met the enemy broadside on at short range and were thus able to destroy them," implying flanking shots were his only way of defeating enemy armor. While it may be true the Challenger also gave him the means to engage frontally, the Nederwetter example clearly shows how much easier things can be when this isn't necessary, when the tank that sees first can also shoot first and kill first without needing the intervention of a specialist tank destroyer to do it for him. In other words, the Challengers could be left in reserve because the Cromwells, thanks to their flanking position, were just as capable of destroying the Panthers by themselves. There was no need for a complex overwatch like with B Squadron at the windmill, or sneaking the Challenger forward as Egerton would do at Liesel a few days later, because at Nederwetter the Cromwells could spot first, shoot first and kill first, as their flanking position meant they weren't faced with armor they couldn't penetrate. Both Egerton and Nesbitt's gunners scored first-round hits on moving tanks that would have escaped had they been forced to hold their fire and wait for the Challenger. What this shows then is the ideal tank battle. Concealed, stationary tanks engaging moving enemy tanks unaware of their presence and scoring knockout hits with their first shots. No need for special tank destroyers or time-consuming battle drills, but a simple case of the tank that sees first, shoots first and kills first. Unfortunately for many undergunned Allied tanks, such a quick and decisive engagement against Panthers was only possible at short range from the flank. That concludes the second part on practice. Feeding the findings from the case study back into the bigger picture is best done in levels, starting with a narrow scope by analyzing just the tank-on-tank engagements, then zooming out to an intermediate scope by looking at the overall battle, and concluding with a broad scope overview that integrates the practical example into the background theory discussed in part 1. Starting with a more analytical look at just the tank-on-tank engagements, there were a total of 5 direct actions between the Hussars and the 107th Armoured Brigade on the 20th of September, all resulting in victories for the Hussars and the destruction of the German tank. Panther No. 1 was destroyed sometime in the early to mid-morning by a Challenger of B Squadron with a single shot through the front armor at approximately 800 to 900 meters, resulting in an immediate fire. The Panther was stationary and fired the first shots at B Squadron tanks when the Challenger returned fire with the help of an external spotter. Panther No. 2 was destroyed sometime in the mid to late morning by a Challenger of C Squadron with a single shot through the left side at approximately 300 to 400 meters, resulting in an immediate fire. The Panther was moving and unaware of the enemy presence. The Challenger was guided on target by an external spotter. Panther No. 3 was destroyed around 1300 hours by a Cromwell of A Squadron with a single shot through the right side at approximately 600 to 700 meters, resulting in an immediate fire. The Panther was moving and unaware of the enemy presence. The Cromwell engaged on its own without an external spotter. Panther No. 4 was disabled around 1300 hours by a Cromwell of A Squadron with a single shot to the right side at approximately 600 to 700 meters, resulting in a severed track. The Panther was moving and unaware of the enemy presence. The Cromwell engaged on its own without an external spotter. Panther No. 5 was destroyed around 1340 hours by a Cromwell of A Squadron with 4 shots through the right side at approximately 600 to 700 meters, eventually resulting in a fire. The Panther was moving and unaware of the enemy's exact location. The Cromwell engaged on its own without an external spotter. This data aligns with broader statistical trends as well as the fundamental principles of tank warfare. In most cases, a stationary tank that spots first, shoots first and penetrates first wins the engagement against a moving tank that is unaware of the enemy's presence, proving that a tactical advantage in positioning and surprise can negate technical disadvantages in protection and firepower. Hits were scored at an average range of 700 meters, which was typical for Western Europe. The hull was most often struck, the first penetrating hit decided the engagement, and internal fires fully destroyed the tanks. Panther No. 4 was perhaps not penetrated, but still immobilized and abandoned after a single shot to the side. Panther No. 5 received 4 hits in the side, but was likely combat ineffective after the first round, the additional 3 setting it on fire to confirm its destruction. One notable anomaly is the 100% first round hit rate, which may be explained by the Hussars' high standards of training and the fact that they mostly engaged unaware opponents from ambush positions. Another noteworthy trend is that both Challengers had to be guided on target by a spotter standing outside the tank, whereas the Cromwells spotted and engaged their own targets. This was likely due to the emphasis on careful and deliberate use of the Challenger, meaning it was kept back in a concealed position where it was safer but could see less on its own. The one outlier is the first engagement, as the roles were reversed. The Panther was stationary and fired first at moving B Squadron tanks, but only scored non-penetrating hits before being taken out by a Challenger through its frontal armor. It's unfortunate the sources don't provide more details, as this is the one engagement where the Challenger's 17-pounder really made a difference, knocking out a stationary Panther with secured flanks at relatively long range. It also had the greatest consequences, as this first loss seems to have caused the remaining 4 tanks to retreat and fatally expose their flanks. The conclusion for the narrow scope then is that the Challenger played a small but crucial role in the overall battle. Most Panthers were destroyed by the more numerous Cromwells or hit from such a range and angle that a Cromwell could have done it. But on the one occasion when a Challenger was actually needed, it was available, put in the right place at the right time, and successfully carried out its tactical role by protecting the Cromwells against heavy German armor. Taking a step back to the intermediate scope, what stands out is how much of the bad German performance was due to the poor tactical situation they found themselves in. After a short training period, the 107th Brigade was hastily deployed to an unknown sector without liaison with nearby units, given unrealistic orders from an unfamiliar headquarters, a timetable forcing a piecemeal deployment, objectives 50 kilometers away from their railheads, insufficient fuel and no flank protection. The brigade came without adequate reconnaissance troops, no bridging and no artillery, and was only reinforced with a poorly trained light infantry battalion. They advanced under constant threat of air attack and were being monitored by local resistance networks in contact with the Allies. Despite this, they still had a chance of overrunning Son on the evening of the 19th, but failed to push through their surprise attack and instead waited until the following morning when they were outnumbered and facing counterattacks from the south. Above all, the local landscape, with its many water barriers, prevented any form of mechanized maneuver around their objective. There was no way for tanks across the Wilhelmina Canal to their north, and only one exposed choke point over the Dommel to their west. The war diary of the German Tank Battalion states plainly that their attack on the Somme Bridge encountered strong resistance, but above all, impassable train obstacles. While the local waterways frustrated German attacks into Son, Weatherby Force successfully crossed the Dommel further south, gaining the element of surprise and opening the way to a devastating cutoff position. Their lighter weight and smaller size gave British tanks an advantage over the heavy Panther tanks that could not cross the Soeterbeek Bridge, although it should be noted that the German objective had changed from Eindhoven to Son, meaning the bridge was no longer a relevant crossing point for them. The German mistake at Soeterbeek was not offensive but defensive, as they failed to deny the crossing to lighter Allied tanks. What the intermediate scope makes clear is that a technological advantage in tank design can only be leveraged under the right tactical circumstances, and these are mostly dictated by the terrain and the mission. While the Panther may have been superior to Allied tanks when defending in an open field at long range, going on the attack in dense terrain with open flanks and limited room for maneuver squandered many of its advantages. Its great gun could not find targets, its thick frontal armor was bypassed from the flank, and its mobility meaningless if it could not cross rivers or canals. This doesn't mean Panthers were useless or lighter tanks would have fared any better, because the German brigade was in a poor spot regardless of its equipment. That this fairly small force could still cause so much trouble to Market Garden was largely due to the Panthers. Their position at the junction of the Dommel and Wilhelmina Canal secured their flanks and let them cut the road to Arnhem with fire, strangling the entire Market Garden operation with just 5 tanks. Older German tanks would have been vulnerable in this position, as American AT guns or British Cromwells could pierce their frontal armor, but precisely because they were Panthers, it took nothing short of a Challenger to dislodge them. Meanwhile, at Nuenen, Panther tanks held off 2 squadrons of Shermans without suffering losses, proving it was still a very dangerous tank under the right circumstances. What the case study shows above all is that the success of any tank, no matter how capable on paper, is ultimately dependent on where, when, and how it is used, who is using it, how they are sustained, and how they are supported. Any tank will suffer if the crew is poorly trained, fuel is lacking, attacks are poorly planned, combined arm support is absent, and flanks are left open. Conversely, a tank that is inferior on paper can still be very successful if maneuvered into the right position with proper support, as was demonstrated so clearly by the Cromwells of Weatherby Force. Finally, the broad scope ties together the overall story of the Challenger by holding up the case study as a mirror to see if the theoretical points raised in Part 1 on doctrine, design, organization and tactics are reflected by the real-world example. Starting with doctrine, this chapter mainly looked at the theoretical origins of the cruiser tank as successor to the cavalry's exploitation role and how Second World War combat experience molded British doctrine away from this rigid specialization and towards a preference for a single type of balanced universal tank that could both support the combined arms team, pursue the enemy, and fight other tanks. This change was still underway in 1944, meaning the Hussars went to battle with a hybrid doctrine. On the one hand, their Cromwells were still technically cruisers, retaining a characteristically low profile and high speed, but their dual-purpose armament and use within a combined arms team had pushed them closer to the doctrinal role of a universal tank. Where they fell short was their inability to effectively fight enemy armor, but this was partially mitigated by the 1 in 4 complement of Challengers as stopgap tank destroyers. The dormant cruiser legacy of both Cromwell and Challenger resurfaced in the weeks leading up to the battle during the high-speed pursuit through France and Belgium. But as German resistance increased in September, cavalry dash again made way for deliberate combined arms. Still, during the tank battle on the 20th, a few cruiser characteristics stood out. No doubt, the greatest display of their tactical mobility was Weatherby Force crossing the Soeterbeek Bridge. Another noteworthy example was the rapid redeployment of A Squadron's 2nd Troop from Pearson Force to Weatherby Force. Meanwhile, the Cromwell's deceptively low profile aided Weatherby Force in staying concealed outside Nederwetten. It may also have saved B Squadron's HQ tanks at the Son windmill from taking a mortal blow as the Panther aimed too high. However, the benefits of a more balanced tank design, especially in regards to firepower, were made even clearer. The devastation that B Squadron caused as they routed the German infantry west of the Dommel was made possible by their dual-purpose guns firing potent HE shells, something earlier British cruisers would have struggled to replicate with their single-purpose AT guns. On the other hand, the inferior armor-piercing firepower of the Cromwells made them considerably less flexible when facing enemy tanks, leading to missed opportunities. B and C squadrons only destroyed one tank each because they relied on their Challengers to do the work, leading to long and time-consuming kill chains that involved intermediate spotters guiding single Challengers in position and on target. Weatherby's Cromwells, by contrast, showed how quick and decisive a tank engagement can be when the kill chains are short and the tank that spots the target can also engage and destroy it on its own. Finally, the case study clearly displays the importance of combined arms teamwork. The Hussars were more than just tanks. They were reinforced with a squadron of armored cars and a battery of self-propelled artillery and placed under the command of an American airborne division. Throughout the battle, the different arms worked closely together as a team. The scouts provided intelligence and security, the artillery indirect fire, B Squadron supported the glider infantry, and tank-riding paratroopers escorted Weatherby Force. In terms of doctrine, the case study exemplifies the important shift towards flexibility in both tank design and use. Instead of making specialist tanks to fulfill specific roles on their own and not use them for anything else, it is better to have a universally capable tank at the right place at the right time that can work together with the other arms, exploit opportunities, and fight enemy tanks on an equal footing. The chapter on design dealt with the Challenger's unique mix of mobility, protection, and firepower, and how this led to confusion over its proper use, with some arguing its armor was too thin to be a battle tank and that it was better suited for the more limited role of a self-propelled gun. While the Liesel example in Part 1 showed these concerns were justified, the Son case study demonstrated the age-old adage that armor is not needed if you don't get hit in the first place. This is a lot easier said than done, but the Hussars managed it through teamwork and good use of the available train. Mobility-wise, the Challenger distinguished itself from the Sherman Firefly by keeping up with the speedy Cromwells, the rapid redeployment of 2nd Troop to the aid of Weatherby Force being the most notable example. Armor-piercing firepower was of course the Challenger's most important feature, and this was on full display during the first tank-on-tank engagement across the Dommel. The 17-pounder proved capable of defeating a Panther head-on in real-world conditions, aided by the fact that it faced a late production model with lower quality armor plates. In terms of design, the battle at Son offers a perfect example of the Challenger doing exactly what it was made for, keeping up with the Cromwells and protecting them against heavy German armor, in turn enabling the Cromwells to benefit the combined arms team. The chapter on organization mainly looked at the allocation of 17-pounders and whether to disperse or concentrate them. The Hussars followed the recommended procedure and went for troop-level dispersion. Even when tanks were lost, troops merged or squadrons split up, they made sure every remaining fighting unit had at least one Challenger at its disposal, meaning the German Panthers were faced with a dangerous 17-pounder gun whenever and wherever they encountered British tanks. In hindsight, this wasn't needed, and a concentrated use of all available Challengers at the B Squadron position would have been ideal, but there was no realistic way the regimental commander could have anticipated this. In mobile armored warfare, a misjudged concentration of limited assets at the wrong time or place can have disastrous consequences. Especially the deployment of the Hussars into 4 fighting units spread out over a battlefield intersected by rivers and canals made dispersed troop-level AT assets a necessary precaution. A concentration of Challengers at Son could never have come to the aid of Weatherby at Nederwetten had things gone differently. Simply put, if the average tank cannot reliably deal with enemy armor, it is better to have a single tank destroyer nearby than 12 of them far away. Finally, the chapter on tactics investigated the best ways to use the 1-in-4 troop organization, concluding that a single 17-pounder tank destroyer was an awkward but necessary addition to the troop, best used carefully and deliberately and only when actually faced with heavy enemy armor. The case study showed that this was indeed done, but also reviewed a broad range of minor tactics being applied by the different squadrons depending on their specific situation. B Squadron put a Challenger in an overwatch position to cover the advance of 2 HQ tanks, allowing it to quickly retaliate when a Panther revealed itself by firing. C Squadron carefully brought a Challenger into a sniping position behind the canal embankment, using scouts to clear the way and guide it on target. Weatherby Force held its Challenger back as a flank guard, letting Cromwells do the shooting as long as they were getting side shots. What this shows is the enduring relevance of basic tactical principles, regardless of temporary technological advantages or disadvantages. While there was a real and sometimes dramatic asymmetry in the combat capabilities of Second World War tanks, most tank-on-tank engagements were not decided by armor thickness or muzzle velocity alone, but by the proper application of tactical fundamentals like mutual support, clever use of train, and surprise fire from the flank. What then was the Challenger? At the time, it was a stopgap tank destroyer that put a 17-pounder on a Cromwell. But now, the one remaining Challenger provides us a window into broader topics of doctrine, design, organization, and tactics, and serves as a reminder of the battle where it really made a difference. This has been Ivo van der Spoel, and thank you for watching Digital Battlefield Tours.